Welcome to Quiet Universe, where we dive deep into the wonders of space, mysteries of the cosmos, and the questions that keep us awake at night. Tonight, we're embarking on a fascinating journey through some of the most captivating moons in our solar system. Each of these moons holds stories of intense volcanic activity, hidden oceans, alien landscapes, and mysteries yet to be uncovered. Imagine standing on the icy surface of Europa, with Jupiter looming overhead, or exploring Titan's methane lakes, where the environment is so alien, it feels like stepping into another world. Moons like Triton, with its icy geysers, and Ganymede, the largest moon in the solar system, beg us to ask, what else could be hiding beneath their frozen surfaces? Even our own moon, with its ancient craters and its vital role in shaping life on Earth, still has secrets to offer. From the volcanic chaos of Io to the serene surface of Enceladus, each of these celestial bodies reveals something about the past, present, and perhaps the future of our solar system. So, buckle up as we take you through the most intriguing moons, starting with the icy worlds of Saturn and Jupiter, all the way to the lonely companions of Mars and beyond. Stay tuned as we explore these remarkable satellites in depth. Each of them may just redefine the way we think about life beyond Earth. Titan, Saturn's largest moon, feels like a place caught between the familiar and the completely alien. It is a world where something as ordinary as rain falls from the sky. Yet the rain isn't water but liquid methane, and the rivers and lakes it forms aren't like anything we know on Earth. Imagining standing on Titan, you would find yourself in an amber-tinted landscape with a hazy atmosphere thicker than Earth's. Breathing wouldn't be an option. The air is primarily nitrogen, with methane and other gases that would be toxic to us. Yet, despite its hostile environment, there is something about Titan that makes you feel as if it has all the makings of a place that could have, or may still, harbor some form of life. Beneath its thick layers of clouds, Titan hides a surface sculpted by forces both strange and oddly familiar. Those methane lakes and rivers are eerily reminiscent of Earth's hydrological cycle, but with liquid hydrocarbons playing the role of water. It's as if you were looking at a twisted reflection of home. A world with rivers that run and seas that lap at mysterious shores, but they're filled with liquid that would kill you on contact. You can almost hear the eerie silence as those lakes sit still beneath the perpetual haze. No wind to stir them except the occasional methane rainstorm. There's an even stranger secret beneath Titan's icy shell. Beneath the crust of frozen water ice, scientists believe there may be an ocean of liquid water, kept from freezing solid by the gravitational forces of Saturn tugging on the moon, generating heat deep within its core. The thought that an ocean could exist in the darkness, far from any warmth of the sun, is unsettling. What if, in that hidden ocean, something lives? The idea teeters on the edge of possibility. Microbial life, or something even more complex, adapted to a world so foreign to us it would be almost impossible to imagine what it might look like. Titan's landscape, with its dunes of frozen hydrocarbon particles and towering ice mountains, adds to the mystery. Those dunes stretch for hundreds of miles, sculpted by winds that drift across the surface at a speed that would hardly ruffle your hair, but over millennia have shaped Titan's terrain. If you were to wander across those dunes, the ground beneath you would crunch in a way that feels familiar, yet you'd always be reminded that this isn't Earth. It's a place far removed, a world frozen in time. There is another puzzle that keeps drawing us back to Titan: its thick atmosphere. It's the only moon in the solar system with a dense atmosphere, a mix of gases not entirely unlike the primordial atmosphere Earth once had. It's thick enough to potentially shield life from harmful radiation, thick enough to allow for weather patterns and even seasonal changes. In that way, it holds a sense of possibility. You could almost imagine Titan in a distant past, evolving under a blanket of clouds, holding onto some spark of life, or perhaps in the distant future, as a place where humans might one day walk without fear, manipulating its environment to suit our needs. Titan's atmosphere also sparks other mysteries, ones that linger in the unseeable reaches of its weather system. Where does all that methane come from? Methane should break down under the weak sunlight that reaches Titan, yet it persists. Some speculate that there's an unknown source beneath Titan's surface, perhaps cryovolcanoes that spew icy, methane-rich slush instead of molten rock. These volcanic eruptions might shape the moon's geology in ways we can only begin to guess at, reshaping the landscape while leaving us to ponder what else might lie within its depths. And then, of course, there's the enigma of the future. Titan, with all its similarities to Earth's processes, also offers us a mirror for what a colder, darker world could become. It's a place where chemistry, geology, and the potential for life intersect in ways we've only scratched the surface of. What could we learn from Titan? What might it teach us about our own planet, about life elsewhere in the cosmos? The answers seem to hover just out of reach, locked beneath layers of ice and time, waiting for someone to finally make sense of its secrets. To stand on the shore of Titan's methane seas is to feel both awe and unease. It's the familiarity that unsettles the most. Rivers, seas, clouds, but all made from the wrong materials, behaving just slightly wrong. Titan is like a memory of a place we've never been, both comforting in its resemblances to Earth and deeply alien, reminding us how little we truly know about the universe and the strange worlds that hide within it. The thought of what could be hidden beneath Titan's ice, or the forces that continue to shape its surface, is both humbling and thrilling. It's a reminder that some of the greatest mysteries aren't found at the edge of the universe, but right here, in our own cosmic backyard. Europa, a distant moon orbiting Jupiter, feels like a world pulled straight from science fiction, but its existence is entirely real, and its mysteries are tantalizingly within reach. The first thing that strikes you about Europa is its ice. The surface is an unbroken sheet of frozen water, stretching endlessly under the pale light of the distant sun. This ice is scarred with cracks and streaks, resembling veins running through the moon's skin, but it's not just any ice. It's hiding something extraordinary. Beneath that frozen surface, scientists believe, lies a vast ocean of liquid water, perhaps twice the volume of all Earth's oceans combined. It's a thought that takes a moment to fully grasp. An entire ocean buried under miles of ice, on a moon over 390 million miles from Earth. What makes Europa even more fascinating is that this hidden ocean may not be just a frozen wasteland. The gravitational tug from Jupiter constantly pulls at Europa's core, generating heat through friction deep within the moon. That heat might be enough to keep the ocean warm and, more incredibly, it could create the right conditions for life. The idea of life, however simple or complex, surviving in those deep, dark waters is something that lingers in the imagination. You can almost picture strange creatures swimming through the black, under the eternal ice, never seeing the sun but thriving in a world of extremes. The cracks on Europa's surface, those long, jagged lines, tell a story of this internal activity. They are the result of the ice shifting, fracturing, and refreezing as the forces from below push and pull at the surface. Some of these fractures are so recent that they suggest the ice is still in motion, sliding and cracking as the ocean shifts beneath it. If you could stand on Europa, you might hear the eerie groaning of the ice as it moves. A world constantly in flux, its surface never entirely still. But it's not just the ice and water that make Europa such a compelling place. There's something deeply unsettling about a world where water, the very substance we associate with life, is locked away under a barrier we can't easily breach. It's an invitation, a challenge almost, for humanity to find a way to break through and explore what lies beneath. The thought that microbial life could be swimming in Europa's ocean, sustained by hydrothermal vents similar to those in Earth's deep oceans, feels almost too good to be true. But it's not impossible. Those same vents, spouting heated minerals into the dark water, might be providing the nutrients needed to sustain a hidden ecosystem far beyond the reach of sunlight. Even Europa's thin atmosphere holds intrigue. Composed mainly of oxygen, it's not the kind we could breathe, but it's enough to make us wonder how oxygen could form and persist in such a remote place. Some suggest that radiation from Jupiter's magnetosphere might be splitting water molecules on the surface, releasing oxygen into the atmosphere. But there's more to it than just speculation. If radiation can split those molecules, it also means that Europa's surface is constantly being bombarded by high-energy particles, a place where any potential life would need to hide far beneath the ice to survive. Europa feels like a place of contrasts, a frozen surface masking the possibility of warmth and life beneath, an atmosphere we can't breathe, but one that hints at processes we still don't fully understand. It's not a world that gives up its secrets easily. It challenges our assumptions about where life can exist and what forms it might take. And that challenge is part of what makes Europa so captivating. You find yourself wondering not just what could be hidden in its deep oceans, but what it means for the rest of the universe. If life can exist in such an extreme environment, could it also thrive in places we once thought were dead and barren? It's impossible to look at Europa without feeling a sense of wonder about the universe we live in. It shows us that life might not be confined to Earth, that oceans can exist in the most unexpected places, and that the conditions for life are far broader than we once believed. It leaves us with questions that feel urgent and profound. What does it mean if we find life there? Would it be a reflection of life on Earth, or something completely foreign? And how would knowing we are not alone reshape our understanding of our place in the cosmos? Europa is a world that stirs something deep within us. It's both familiar and alien, a place where water, our most essential resource, is abundant but inaccessible, hidden under a surface that has been frozen for eons. The thought of what might be waiting beneath, swimming in darkness, brings a shiver of excitement and mystery. It reminds us that the universe is full of surprises, and that the answers to some of the biggest questions may be found in the smallest, coldest, and most distant places. Triton, Neptune's largest moon, is a place where nothing seems to follow the rules we've come to expect from other moons. As you imagine standing on its frozen, wind-swept surface, the first thing you notice is the cold. Triton is one of the coldest places in the solar system, its surface temperature hovering around -235 degrees Celsius, just 38 degrees above absolute zero. But it isn't just the cold that sets Triton apart. It's the way everything seems to work backward. Triton orbits Neptune in the opposite direction to the planet's rotation, a retrograde orbit that suggests it didn't form alongside Neptune but was captured, likely pulled in from the Kuiper Belt, a distant region of icy bodies at the edge of the solar system. The thought of Triton being a former wanderer, now bound to Neptune, adds a strange layer of melancholy to the moon's story, as if it was once free but is now tethered forever to its massive blue planet. As you picture the landscape, what you might expect to be static and dead is anything but. Triton's surface is a chaotic mix of frozen nitrogen, methane, and water ice. Yet it's not a still, frozen world. Below its crust, there are forces at work. Cryovolcanoes that spew plumes of nitrogen gas and icy particles high into the thin atmosphere. These geysers, powered by heat from Triton's core, are a stark reminder that even in the most distant, frozen corners of the solar system, there's activity. The idea of volcanoes erupting not with molten rock but with nitrogen frost is unsettling, a sharp contrast to the volcanic activity we're used to on Earth. The geysers themselves are so powerful they leave dark streaks across Triton's surface, like scars left behind by invisible forces. Triton's retrograde orbit, combined with its geological activity, hints at a violent past. As a captured moon, its original orbit likely changed drastically when it was pulled into Neptune's gravitational field, causing immense tidal forces that could have melted its interior. Those early days might have been chaotic, with internal friction generating heat, reshaping Triton's surface and leading to the icy volcanic activity we still see today. It's a reminder that Triton, despite its distance and its frozen surface, has had a dynamic and possibly tumultuous history. Then there's the strangeness of its surface features, some of which look like giant cantaloupe skin. Vast regions of Triton are covered in what's known as cantaloupe terrain, a bizarre landscape of pits and ridges that scientists still don't fully understand. It's unlike anything seen elsewhere in the solar system, leaving us to wonder what could have caused such a strange, alien pattern. You find yourself imagining walking across that terrain, the ground uneven and pitted, not knowing what lies beneath your feet or how deep those pits might go. Triton also has a tenuous atmosphere, one that's much thinner than even Mars, composed mostly of nitrogen with traces of methane. Despite how thin it is, it's still dynamic, with seasonal changes and hazes that form as nitrogen and methane freeze and evaporate. For a moon so far from the sun, where you'd expect nothing to change, Triton's atmosphere offers a surprising amount of variation. It's as if the moon is breathing in slow, frozen cycles, its surface and atmosphere interacting in ways that seem almost alive. Perhaps the most unsettling thought about Triton is its future. Slowly but surely, Neptune's gravity is dragging it closer, pulling Triton into a death spiral that will eventually cause the moon to break apart. In a few billion years, Triton will be torn to pieces, its debris forming a ring around Neptune, similar to the rings we see around Saturn. Knowing that Triton is on a doomed trajectory, that its orbit is taking it toward a slow but inevitable destruction, adds an eerie sense of transience to the moon. It's a place that won't last forever, a world with a ticking clock, and yet, despite its frozen desolation, it remains a place of motion, activity, and mystery. Triton's combination of backward orbit, volcanic frost, strange terrains, and its doomed future makes it one of the most mind-boggling moons in the solar system. It's a place where the rules seem to bend, where the cold doesn't necessarily mean lifelessness, and where even the most distant and frozen world can surprise us with its complexity. The idea that Triton, a captured moon, could hold such a dynamic history and face such a dramatic future feels like a cosmic story waiting to be fully understood, one that reminds us that the universe is full of places that defy easy explanation. Ganymede, the largest moon in the solar system, looms in the shadow of Jupiter like a silent giant, and it's hard to wrap your mind around just how immense it really is. Bigger than the planet Mercury, Ganymede feels more like a planet in its own right, yet it's locked in an orbit around Jupiter, pulled and influenced by the gas giant's massive gravitational force. As you picture it, Ganymede's surface looks like a frozen world at first glance, a place covered in ice and craters. But beneath that icy crust, the story becomes far more intriguing. Like Europa, Ganymede is thought to hide a deep ocean beneath its surface, an ocean that may contain more water than all of Earth's oceans combined. The idea that such a massive body of water exists under miles of solid ice on a moon millions of miles away is enough to make you pause, imagining what strange, hidden life forms might be drifting through its dark, submerged depths. What truly sets Ganymede apart from other moons isn't just its size or its ocean. Ganymede has a magnetic field, the only moon in the solar system with one. That field, generated by a liquid iron core similar to Earth's, acts as a protective shield, interacting with Jupiter's powerful magnetosphere in ways that still puzzle scientists. You can almost picture it, a moon so large and complex that it produces its own magnetic field, surrounded by bands of charged particles that light up the sky with auroras at its poles. These auroras are more than just a spectacle. They hold clues about the moon's hidden interior, suggesting that salty water below the surface might be conducting electricity, creating a deeper connection between Ganymede's ocean and its magnetic activity. Ganymede's surface, however, tells a different story. Crisscrossed with grooves and ridges, it's a landscape scarred by the passage of time. Yet in some places, it looks as though tectonic forces have pushed the ice into strange, ridged patterns, almost as if the moon itself is shifting and changing beneath the frozen shell. You imagine walking across that icy terrain, hearing the groaning of the ice sheets as they strain under invisible forces, knowing that an entire ocean lies beneath your feet. It's an unsettling thought, the idea that such a massive, frozen world could be alive with movement, not at the surface, but in the hidden layers below. Another mind-boggling aspect of Ganymede is its relationship with the other moons of Jupiter. Locked in a gravitational dance with Europa and Io, Ganymede's orbit is in perfect resonance with these moons, meaning that for every one orbit Ganymede makes, Europa completes 2 and Io completes 4. This orbital resonance isn't just a coincidence. It helps maintain the gravitational pull that heats the moons, particularly Io, with its active volcanoes, and Europa, with its potential ocean. The thought that Ganymede's massive presence plays a role in shaping the fates of its neighboring moons adds a sense of interconnectedness, as if this distant region of the solar system is a finely tuned clock, each moon playing its part. Even the age of Ganymede is a point of wonder. It's thought to be nearly as old as the solar system itself, its surface a patchwork of ancient, heavily cratered regions and younger, smoother areas. Some regions are so old that they've been frozen in time for billions of years, while others have been reshaped by tectonic forces. The combination of ancient and new on a moon that's been orbiting Jupiter for eons feels like a living history, a timeline written in ice and rock, waiting to be explored. Ganymede is a place that defies simple classification. It's a moon with the mass of a planet, an ocean hidden beneath its icy crust, and a magnetic field that hints at a complex, dynamic interior. It's a world that feels like it's more than just a moon, a place where water, ice, rock, and magnetism combine to create something far more intricate than we once thought possible. And with each discovery, Ganymede pushes the boundaries of what we think we know about moons, planets, and the very definition of life itself. It's a place that challenges the imagination, forcing us to reconsider what's possible in the distant reaches of the solar system. Io, Jupiter's most volatile moon, is like no other place in the solar system. The moment you begin to picture its surface, it's not the icy calm you might expect from a distant moon, but rather a landscape constantly torn apart by forces deep within. Volcanic activity rules Io in a way that feels almost unsettling. Its surface is littered with hundreds of volcanoes, some of which erupt with such intensity that they send plumes of sulfur and volcanic gases hundreds of kilometers into space. You can imagine standing on Io's rugged terrain, the ground trembling underfoot, and looking up to see a massive volcanic plume painting the sky in shades of orange and yellow. It's a world of chaos and fire, where the very ground beneath you is restless, always threatening to explode. What makes Io truly mind-boggling is the sheer scale of its volcanic activity. It isn't just another volcanic moon. It's the most geologically active object in the entire solar system. The cause of this intense activity lies in its unique position, caught in a gravitational tug-of-war between Jupiter and the neighboring moons Europa and Ganymede. Io is constantly squeezed and stretched by tidal forces. This endless kneading generates enormous amounts of internal heat, melting the interior and fueling its relentless volcanic eruptions. It's as if the moon is constantly being tortured by invisible hands, its surface cracking open to release the pressure building up inside. The thought of this constant internal struggle feels almost alive, as though Io itself is a living, breathing entity, always on the edge of bursting apart. Io's surface, when viewed from a distance, appears strangely colorful, almost otherworldly in its yellows, oranges, and reds. These bright hues aren't the result of vegetation or mineral deposits, but vast layers of sulfur compounds sprayed across the surface by its many volcanic eruptions. Some regions are coated in frost from sulfur dioxide, creating a bizarre mix of freezing cold and burning heat, a place where extremes meet. The landscape is pocked with lava lakes and molten rivers, where temperatures soar to over 1,200 degrees Celsius in some areas. You can almost feel the heat radiating from those fiery pits, knowing that beneath the thin, rocky crust, an ocean of molten rock churns restlessly. Adding to Io's unsettling beauty are its towering mountains, some of which reach heights far greater than Earth's tallest peaks. These mountains, though not formed by tectonic activity as they are on Earth, rise up from Io's tortured crust, pushed upward by the intense volcanic forces below. It's strange to imagine such enormous, jagged peaks in a place where everything seems so unstable. The sight of these towering formations, standing firm amidst the chaos of erupting volcanoes, is a reminder of the strange duality that Io represents, an interplay of creation and destruction that feels as ancient as the universe itself. Despite its fiery nature, Io plays a crucial role in shaping Jupiter's magnetosphere. As volcanic gases are blasted into space, they become ionized by Jupiter's immense magnetic field, creating vast clouds of charged particles that help power the planet's auroras. Io, though seemingly fragile and unstable, helps drive one of the most powerful forces in the solar system. You can almost see the invisible connection, the electric current running between Io and Jupiter, a lifeline of sorts, one that binds the two in a relationship of energy and influence. Io's combination of extremes makes it one of the most fascinating and dangerous places in the solar system. It's a world where fire reigns, where the ground beneath your feet is never still, and where the very air around you is filled with the scent of sulfur and the glow of volcanic light. It's a place of raw, unrestrained power, a moon that forces you to confront the violent processes that shape worlds. Io, in its fiery heart, reminds us that the universe is a place of intense, untamable energy, beautiful in its chaos, terrifying in its might. Enceladus, though one of the smaller moons in the solar system, holds a secret beneath its icy surface that has captured the attention of scientists and dreamers alike. At first glance, it seems like just another frozen world orbiting Saturn, its surface gleaming with ice crystals and reflecting sunlight like a mirror. But the deeper you look, the more it reveals. Imagine flying over this moon, seeing giant geysers shooting out into space from its south pole, plumes of water vapor mixed with organic compounds spraying into the blackness. It's not just a spectacle. It's a sign that something extraordinary is happening beneath the frozen crust. Enceladus is an icy world, but under that shell lies a global ocean, kept warm by tidal forces from Saturn's gravitational pull. The idea that there's liquid water on this distant moon, hidden beneath layers of ice, is mind-bending in itself. But even more intriguing is what that water could mean for life. These plumes are not just a curiosity. They are windows into the ocean below. As you watch them erupt, you can't help but wonder about the chemical ingredients they carry. Through the gaps in the ice, organic molecules are being ejected, along with tiny ice particles and salts. The discovery of these compounds makes you think of Earth's hydrothermal vents deep under our oceans, where life thrives in total darkness, feeding on the minerals and heat from the planet's interior. Could something similar be happening in the depths of Enceladus? The possibility feels almost tangible. The plumes suggest that the ocean isn't just cold and dark. It's active, filled with chemical reactions that could potentially support microbial life. It's strange to imagine that life might exist in such an alien environment, where sunlight never reaches, and yet everything needed for life seems to be there, swirling beneath the ice. The very fact that Enceladus is geologically active is a mystery that defies easy explanation. Its surface is covered in fresh ice, constantly renewed by the same geysers that eject material into space. Unlike many other moons in the solar system, Enceladus has very few craters, a sign that its surface is being constantly reshaped. You can almost feel the quiet restlessness of the moon, the slow but steady churning of water below the crust, the gradual buildup of pressure that eventually releases in a spectacular plume. It's a world in motion, not dead or frozen, but alive in its own way, constantly interacting with Saturn's powerful gravity to generate heat and keep its hidden ocean from freezing solid. Another mind-boggling aspect of Enceladus is the connection it shares with Saturn's rings. The particles from its geysers aren't just lost into space. They contribute to the formation of Saturn's E-ring, a diffuse ring that orbits the planet. As you stand on the surface of Enceladus, looking up at the majestic rings of Saturn stretching across the sky, you realize that this tiny moon is helping to build them, its own existence intertwined with the beauty of the gas giant's iconic feature. It's a humbling thought that something so small and distant could have such an impact on one of the most recognizable structures in the solar system. The mystery of Enceladus doesn't end with its water or its role in shaping Saturn's rings. There's the question of how it stays warm enough for its ocean to remain liquid. Unlike other moons, Enceladus doesn't have the size or the internal heat to maintain such activity on its own. It's Saturn's tidal forces that do the work, stretching and compressing the moon in its orbit, creating friction deep within that generates heat. It's a delicate balance, one that has allowed this moon to remain an active world rather than a frozen wasteland. And the thought that such complex, dynamic processes are happening on a moon so small, orbiting so far from the sun, challenges everything we think we know about where life might exist in the universe. Enceladus feels like a place where mysteries multiply the deeper you go. Its plumes, its ocean, its connection to Saturn's rings. All of these things suggest that this little moon is far more than just a frozen satellite. It's a world where the boundaries of possibility are constantly shifting, where the potential for life in an environment so far removed from Earth keeps drawing us back, making us wonder what else could be out there, hidden in the darkness of space. The moon, so familiar yet so distant, has been with us for as long as humanity can remember. But the more you think about it, the stranger it becomes. Its surface, pocked with ancient craters and seas of hardened lava, silently reflects the sun's light, bathing Earth in an otherworldly glow every night. Yet, despite its constant presence, the moon holds mysteries that make it feel anything but ordinary. One of the most mind-boggling aspects of the moon is its origin. To imagine that this celestial body, so close to us, may have been formed from a colossal collision between a Mars-sized planet and the early Earth feels almost surreal. Debris from that impact, ejected into space, coalesced into the moon we see today. Every time you look up at it, you're looking at a piece of our planet that was torn away in an ancient cataclysm. The moon is a reminder that even the familiar can have violent, chaotic beginnings. Its effect on Earth is equally astounding. The moon's gravitational pull tugs at the oceans, creating the tides that have shaped our coastlines for eons. This constant pulling, a cosmic dance between Earth and its satellite, isn't just about water. The moon actually helps stabilize Earth's axial tilt, ensuring that our climate remains relatively stable over long periods. Without the moon, Earth's tilt would wobble more erratically, leading to extreme shifts in climate that would make life as we know it much harder to sustain. In a way, the moon is a silent guardian, influencing life on Earth in ways that are easy to overlook but impossible to ignore. It has always been there, guiding the rhythm of the oceans and ensuring that the seasons follow their familiar cycle. Another mind-bending aspect of the moon is its relationship with time. Every year, the moon moves a tiny bit farther from Earth, about 3.8 centimeters to be exact. It doesn't seem like much, but over millions of years, it adds up. There was a time, billions of years ago, when the moon was much closer to Earth and its gravitational influence was far stronger. The tides would have been enormous, crashing against the shorelines with a force we can hardly imagine today. Over time, as the moon drifts farther away, the length of Earth's days slowly increases. In the distant future, days on Earth will last much longer than the 24 hours we're used to. The moon's steady retreat is a reminder of the slow but inevitable changes that happen on cosmic timescales, changes we can barely perceive but that are constantly shaping our world. The moon's far side, often mistakenly called the dark side, is another source of intrigue. We never see it from Earth, thanks to a phenomenon known as tidal locking. As the moon orbits Earth, it always shows us the same face, leaving the far side hidden from view. For centuries, this unseen part of the moon was a source of speculation and mystery. It wasn't until spacecraft finally ventured there that we got our first glimpse of the rugged, cratered landscape that had eluded humanity for so long. It feels strange to think that something so close to us remained hidden for so much of human history, just out of reach, until our technology allowed us to explore it. The moon is also home to evidence of ancient volcanic activity. Though its surface appears cold and still now, there was a time when the moon was geologically active, with lava flowing across its surface. These vast plains of solidified lava, known as lunar maria, are the dark patches we can see from Earth. They remind us that the moon, like so many celestial bodies, has a deep history filled with violent upheavals and transformations. It's hard to reconcile the moon we know now, silent, lifeless, and unchanging, with the one that once had fiery rivers of molten rock coursing across its surface. Perhaps one of the most awe-inspiring things about the moon is the simple fact that humans have set foot on it. Standing on the moon's surface, looking back at Earth hanging in the blackness of space, is an experience that only a handful of people have ever had. The contrast between the barren, lifeless moonscape and the vibrant, blue planet in the distance must have been overwhelming. To think that our species, born on Earth, managed to travel through space and touch the surface of another world feels almost like a dream. The footprints left behind by the Apollo astronauts are still there, preserved in the moon's nearly airless environment. They are a reminder of one of humanity's greatest achievements and a symbol of our endless curiosity. The moon, so close and yet still full of mysteries, is a constant companion to Earth. Its influence on our planet, its strange geological history, and its connection to human exploration make it far more than just a distant object in the night sky. It's a place where time itself seems to stretch, where the scars of ancient impacts remain frozen in place, and where the remnants of our first steps beyond Earth still lie undisturbed. Every time you look at the moon, you are not just seeing a cold, lifeless rock. You are glimpsing a world that has shaped our own in countless ways, a world that continues to fascinate and inspire. Charon, Pluto's largest moon, is a place that defies expectations. When you think of a moon, especially one orbiting a distant dwarf planet at the fringes of our solar system, you might imagine a cold, lifeless rock quietly spinning in the shadows. But Charon is far from being just a mere satellite. Its existence challenges our understanding of what a moon can be. It's almost as if Pluto and Charon form a double-planet system, locked in a gravitational embrace that causes them to always show the same face to each other, an unusual and intimate dance that's rare in the cosmos. This locked orbit feels strangely personal, like two distant companions unable to ever look away from each other, forever bound by an invisible force. What's even more surprising is Charon's size in relation to Pluto. It's so large that it doesn't just orbit Pluto in the way we imagine moons do around planets. Instead, the two bodies orbit a point in space that lies between them, a gravitational balance that hints at how closely tied their fates are. There's something strangely haunting about that. It's not the typical image of a moon quietly circling a planet, but rather a complex relationship where both objects exert significant influence over one another. You get the sense that neither could be fully understood without the other. They are cosmic partners, inextricably linked. The surface of Charon itself offers a landscape filled with unexpected complexity. Instead of being just a dull, icy wasteland, Charon reveals vast canyons that stretch for hundreds of miles, some of which are deeper than the Grand Canyon on Earth. These enormous rifts seem to tell a story of violent upheaval, as though the moon once underwent intense geological activity that cracked it open, leaving behind scars that have persisted for millions of years. Standing on the edge of one of these canyons, you might feel the overwhelming stillness of the place, a frozen silence broken only by the distant view of Pluto hanging in the sky, close enough to seem touchable yet forever out of reach. One of the most mind-boggling things about Charon is its mysterious North Pole, which is stained with a dark red color. It's unlike anything else on the moon and hints at processes we barely understand. Scientists believe that this reddish hue might come from Pluto itself. Gases from Pluto's atmosphere may have drifted across space and frozen onto Charon's surface, where they have been altered by sunlight into these dark, reddish organic compounds known as tholins. It's a strange and poetic thought. Bits of Pluto traveling across the void to land on its companion moon, marking it with a color that feels alien and yet deeply connected to the world it orbits. Charon also offers the possibility that, in its past, it may have had an internal ocean beneath its surface. It's strange to think that a moon so far from the sun, in the coldest reaches of the solar system, could have once harbored liquid water. But the clues are there in the fractures and valleys that crisscross its surface, suggesting that as Charon's internal heat dissipated, the subsurface ocean may have frozen, expanding and causing the surface to crack. This possibility that a moon orbiting a distant dwarf planet could have once had an ocean of its own feels almost unreal. It reminds us that the ingredients for complexity, and perhaps even life, can exist in places we would never have expected. What makes Charon even more compelling is how little we've known about it for so long. Before the New Horizons spacecraft flew past Pluto and its moons in 2015, Charon was just a distant point of light, a name on a list of the solar system's many moons. But now, after that brief encounter, we've seen Charon in all its strange, haunting beauty. The data we received from that mission is still revealing secrets about this moon, piece by piece, reminding us that even the most far-flung corners of the solar system are filled with surprises. Charon, with its deep canyons, mysterious red pole, and intimate connection to Pluto, is more than just a distant satellite. It's a world in its own right, a place where cosmic forces have shaped a landscape of unimaginable scale and beauty, where the history of two celestial bodies is forever intertwined. The thought that such a place exists, so far from the warmth and light of the sun, challenges everything we thought we knew about the solar system's outer reaches. Charon feels like a reminder that the universe is always more complex and strange than we can imagine. A place where even the most distant, quiet moons hold within them stories of great upheaval and quiet, cosmic companionship. Phobos, one of the two small moons of Mars, holds an eerie fascination. It is unlike any other moon in the solar system, its existence wrapped in peculiarities that challenge our understanding of how moons form and behave. Shaped like a lumpy, irregular rock, Phobos doesn't resemble the spherical moons we are accustomed to seeing. It looks almost like a giant asteroid that somehow wandered too close to Mars and was trapped by the planet's gravity. Its surface is marked by countless craters, scars left behind from impacts over millions of years. Among these is the massive Stickney crater, a gouge so large that it nearly destabilizes the entire moon. It's unsettling to think that Phobos could have been destroyed by such an impact, yet it endures, its battered surface a reminder of how fragile these celestial bodies can be. What makes Phobos truly mind-boggling is its orbit. Unlike most moons, which tend to slowly drift away from their planets, Phobos is spiraling inward. Every year, it creeps closer and closer to Mars, inching toward an inevitable fate. In less than 50 million years, it is predicted that Phobos will either crash into the surface of Mars or be torn apart by the planet's gravitational forces, forming a ring of debris around Mars. The idea of this small, silent moon being slowly drawn into the planet it orbits feels almost tragic, as if it's locked in a fatalistic dance that will end in destruction. Phobos is not just orbiting Mars. It is caught in a gravitational grip that will one day be its undoing. The surface of Phobos itself is filled with strange grooves, long and shallow depressions that crisscross its landscape. These grooves have baffled scientists for decades. Some believe they might be caused by tidal forces from Mars, slowly stretching and deforming the moon as it moves closer to the planet. Others suggest that these grooves could be caused by ejecta, debris thrown into space from impacts on Mars itself, that has rained down on Phobos. Either way, these grooves are a visible testament to the forces at work between Phobos and Mars, an ongoing interaction that is slowly reshaping the moon. Perhaps the most unnerving aspect of Phobos is how close it is to Mars. It orbits the planet at a distance of just 6,000 kilometers, far closer than any other moon in the solar system orbits its planet. From the surface of Mars, Phobos appears to move across the sky rapidly, rising and setting in just over 4 hours. Its proximity means that, to an observer standing on Mars, Phobos looms large in the sky, unlike the tiny, distant dots that moons appear to be from Earth. You can imagine standing on the Martian surface, watching Phobos race overhead, a reminder that this small, doomed moon is caught in a race against time, slowly inching toward its inevitable end. There's also a mysterious quality to Phobos when it comes to its origin. Its odd shape and size make it seem more like a captured asteroid than a traditional moon. Some theories suggest that Phobos, along with Mars' other moon, Deimos, might have originated in the asteroid belt and were pulled into Mars' orbit long ago. Yet, the exact story of how Phobos came to be where it is remains elusive. It's difficult to comprehend that such a small object could have such a complicated history, one that we may never fully understand. Phobos feels like a relic, a reminder that the formation of our solar system was full of strange, chaotic events where objects could be thrown from one place to another, captured by the gravity of planets, and set on orbits that would seal their fates millions of years in the future. Phobos is also a tantalizing target for exploration. Because it is so close to Mars, many have considered using Phobos as a stepping stone for human missions to the Red Planet. Its weak gravity would make landing and launching easier than on Mars itself, and from Phobos, astronauts could study Mars from an incredibly close vantage point. There's something fascinating about the idea of setting up camp on this strange, potato-shaped moon, using it as a base to explore one of the most mysterious planets in our solar system. Yet, at the same time, the knowledge that Phobos is slowly dying adds a certain urgency to its exploration. It won't be around forever, and if we want to understand it, we may need to act soon. Phobos, with its odd orbit, mysterious grooves, and doomed future, feels like a cosmic anomaly. It doesn't behave like other moons, and its fate is sealed in a way that feels almost cruel. Yet, for all its strangeness, Phobos offers a unique window into the forces that shape our solar system. It's a reminder that the celestial objects we take for granted as stable and eternal are anything but. The story of Phobos is one of tension, of forces pulling it in different directions, and of a slow, inevitable march toward destruction. Callisto, one of Jupiter's most enigmatic moons, stands out in the vast reaches of the solar system not because of its vibrant activity or volcanic eruptions, but because of its haunting stillness. It is a moon frozen in time, its surface covered in craters that tell a story stretching back billions of years. Unlike other moons of Jupiter, which exhibit signs of tectonic shifts or subsurface oceans stirring beneath the ice, Callisto remains eerily quiet. It feels as if time itself has slowed on this distant world, leaving it unchanged, a relic of the early solar system. Standing on Callisto, you might feel the weight of this stillness, an ancient world untouched by the violence and chaos that shaped so many other moons. The sheer age of Callisto's surface is staggering. It is one of the oldest surfaces in the solar system, with craters overlapping craters in a kind of cosmic layering that stretches back to the moon's formation. Each impact, frozen in place, marks a moment in the solar system's violent past, a time when planets and moons were constantly bombarded by debris. Callisto has preserved these scars like a gallery of ancient wounds, never healing, never smoothing over with the passage of time. It feels almost strange to look at, a surface that bears witness to an age when the solar system was still young and chaotic. Yet beneath this cratered surface, Callisto holds a mystery that challenges our understanding of where life might exist. For a long time, it was assumed that Callisto was nothing more than a ball of rock and ice, devoid of any geological activity. But recent discoveries have suggested that there might be something hidden deep beneath the surface, a subsurface ocean, It's an almost unbelievable thought that a moon so old and seemingly dead could still harbor liquid water far below its icy crust. If such an ocean exists, it would be buried under hundreds of kilometers of rock and ice, far deeper than anything we've seen on moons like Europa or Enceladus. The presence of water, even so far beneath the surface, stirs up the tantalizing possibility that Callisto, against all odds, might harbor the conditions necessary for life. The thought of a subsurface ocean on Callisto is even more intriguing because of the moon's distance from Jupiter. Unlike Europa or Ganymede, which are subjected to intense radiation and tidal forces from the gas giant, Callisto orbits farther out, in a quieter region of Jupiter's gravitational grip. This isolation might have allowed Callisto to retain its ancient surface while preserving a hidden ocean beneath. There's something fascinating about this balance. The idea that Callisto, by staying just out of reach of Jupiter's powerful forces, may have remained a stable world for billions of years, quietly hiding its secrets beneath the surface. Callisto's relationship with Jupiter also adds a layer of intrigue. While many moons of the outer planets are subjected to extreme tidal heating or radiation, Callisto orbits in a relatively calm environment. From the surface of Callisto, Jupiter would dominate the sky, its massive presence looming above like a distant god. And yet, despite its proximity, Callisto remains distant enough to avoid the more violent effects of Jupiter's magnetic field. This balance makes Callisto a place of extremes. The moon exists on the edge of one of the most dangerous environments in the solar system, yet it manages to maintain a sense of calm and stability. Adding to the mystery of Callisto is the fact that it is a prime candidate for future human exploration. Unlike other moons of Jupiter, which are bathed in dangerous radiation, Callisto's distance from the planet means that it could be a safer destination for astronauts. Some have even suggested that a base could be built on Callisto, a place where humans could observe the distant beauty of Jupiter without being exposed to lethal radiation. The idea of standing on this ancient moon, gazing out at the swirling clouds of Jupiter from a safe distance, evokes a sense of awe. It feels like Callisto, quiet and mysterious, might one day become a stepping stone for humanity's exploration of the outer solar system. Callisto is a paradox, a moon that seems frozen and lifeless on the surface, yet might harbor something extraordinary beneath. It is both ancient and mysterious, a world that has quietly existed on the edge of Jupiter's influence for billions of years, untouched by the forces that have shaped so many other moons. Its craters are not just scars but stories, each one marking an impact from a time when the solar system was young and chaotic. And beneath that surface, there may be a hidden ocean, waiting for us to discover its secrets. Callisto reminds us that even the quietest places in the solar system can be filled with mystery, and that sometimes, the most unassuming moons hold within them the most profound possibilities. Miranda, one of Uranus's moons, stands out for its strange and fragmented appearance, as though it was shattered and then crudely stitched back together. This tiny moon, just 470 kilometers across, is one of the most unusual celestial bodies in our solar system. Miranda's surface is marked by huge canyons, ridges, and scarps, some towering up to 20 kilometers high, which seem disproportionate for a moon of its size. The sight of such dramatic geological features sparks a sense of wonder about what could have created these scars. It's like staring at an ancient world that wears the visible marks of violence, leaving clues about a mysterious past that doesn't reveal itself easily. Unlike Earth or our moon, Miranda lacks an atmosphere. The silence here would be deafening, not even a whisper of wind to carry sound, making it feel even more isolated and alien. It's this eerie stillness combined with its chaotic landscape that leaves a haunting impression on the human mind. Standing at the edge of Verona Rupees, the tallest cliff in the solar system, you'd see a sheer drop of 20 kilometers. Imagine that. A place where, because of the weak gravity, you could leap off and it would take over 10 minutes to hit the ground. This small but dramatic detail makes one realize how different the physics are out there. It's so far removed from human experience, yet somehow we're able to grasp its extremes, thanks to the thin thread of scientific exploration that ties us to these distant worlds. The moon's tortured surface raises profound questions. One theory is that Miranda might have been torn apart and reassembled by collisions, its appearance a grotesque patchwork resulting from repeated disruptions. This idea feels raw, like the celestial version of a broken heart that keeps pulling itself back together, scarred and never quite whole. Another theory suggests tidal forces between Miranda and Uranus stretched and distorted the moon. But none of the explanations fully capture the magnitude of its weirdness. What strikes at the core is the randomness, the way such small forces, when stretched over vast timescales, can shape worlds beyond recognition. Miranda feels like nature's experimentation in the extremes, not quite fitting into any tidy category. Miranda's orbit around Uranus also adds to the strangeness. The moon is tilted at a sharp angle due to Uranus's own axial tilt of about 98 degrees. This means that Uranus orbits the sun essentially on its side, and Miranda dances in this skewed alignment, spinning around its parent planet in a gravitational lock, always showing the same face. As a result, from Miranda, the view of Uranus and the distant sun would change in bizarre ways that no human has ever witnessed. This gives it a sense of disconnection from the usual solar system order, something human explorers could only dream of understanding from afar. It's a reminder of how tiny and specific our place is in the vastness of space. Miranda challenges the human sense of pattern, of understanding nature's tendencies, and yet it also awakens a desire to explore further. Its presence ignites that fundamental curiosity about the forces that shape worlds. It's not simply a frozen rock. It's a puzzle that speaks to how even the most remote places have complex stories to tell, stories that will forever remain part of the universe's unfinished narrative. In Miranda, we see chaos, but also the stubborn survival of form and function, a reflection of the chaotic and unpredictable nature of existence itself. Deimos, the smaller of Mars's two moons, feels like a peculiar afterthought in the solar system. It's tiny, just 15 kilometers across, more like a wandering asteroid that Mars managed to capture rather than a proper moon. And that's exactly the mystery. How did it come to orbit the red planet? Its irregular shape, pocked with craters and covered in a layer of fine, dusty regolith, makes it look like a lump of rock you could almost pluck out of space with your hand. Yet it sits out there, on the edge of our consciousness, just beyond reach. There's something unsettling about Deimos, as if its very existence challenges our need for structure and definition in the cosmos. Its small size makes it feel almost too insignificant. Yet here it is, orbiting Mars, the next frontier for human exploration, and somehow, Deimos keeps getting left out of the story. Imagine standing on its surface, or what passes for a surface, where gravity is so weak you could throw a rock, and it might just drift off into space. You would feel a sense of disconnection, almost weightless, with Mars looming large in the sky, an enormous red giant dominating your field of view. It would be an odd feeling, watching the planet beneath you spin slowly, knowing you're tethered to it only by the thin leash of Deimos's weak gravity. And then there's the sky, an empty, black void where the sun is little more than a bright star, casting pale light over the cold, desolate landscape. It's the kind of place that makes you think about isolation, about being so far from home, and yet so close to another world. Deimos's smoothness is puzzling too. Compared to its sister moon Phobos, it's less scarred, less battered by the impacts that have shaped so many other moons and asteroids. There's a sense of calm about it, as though it's been protected, shielded from the worst of the solar system's chaos. Some scientists think that Deimos, like Phobos, might have once been part of the asteroid belt before Mars pulled it into its orbit. But others speculate it could be something even more unusual, an early remnant of the material that helped form the planet itself, a piece of Mars that never quite made it. It's in these speculative details that Deimos becomes more than just a distant rock. It becomes a key to understanding Mars's past, and by extension, our future on the planet. What could Deimos tell us if we ever get close enough to explore its secrets? Its slow drift away from Mars adds another layer of intrigue. Over the millennia, Deimos is gradually moving farther from the planet, an almost imperceptible escape. It's not much, but the idea that one day, this little moon might slip out of Mars's grip and head off into the darkness of space is fascinating. The thought of Deimos floating endlessly, a lonely traveler far from the warmth of any sun, taps into a deep human fear of isolation, of being lost in the infinite expanse. But maybe that's what makes Deimos so captivating. It reminds us of the fragility of the things we think are permanent. Nothing stays forever, not in the cosmos, not even moons bound by gravity. For all its quiet, Deimos is a symbol of resilience. Despite its small size and the harshness of space, it has persisted for billions of years, a silent witness to Mars's history, its cycles of dust storms and ice ages. It's almost poetic that one day humans might stand on Mars, look up at Deimos, and wonder what it must have seen, what it knows about the planet beneath them, and how its existence shaped the path that led us to explore these distant worlds. In Deimos, we see a tiny fragment of the universe's endless complexity, a reminder that even the smallest objects hold stories worth uncovering, and maybe stories that echo our own desire to explore the unknown. Iapetus is a moon that seems to defy logic, a celestial oddity that raises more questions than answers. When you first look at it, it feels as if nature couldn't decide on one color for its surface. One hemisphere is pitch black, almost absorbing all light, while the other is blindingly bright, reflecting it like snow. The stark contrast between these two faces of Iapetus gives it an eerie, dual appearance, almost like a cosmic yin and yang. How could such a phenomenon exist? It's a reminder that the universe often resists our attempts to impose order and understanding on it. As humans, we tend to look for patterns, but Iapetus stares back, challenging us with its deep contrasts, asking us to look closer, dig deeper. The explanation for its two-tone surface might lie in the strange process of space dust and ice migration. Dark material, likely coming from another of Saturn's moons, Phoebe, coats one side of Iapetus, while the other remains pristine. But even knowing this, it's hard not to feel like there's something more profound at work. It stirs a sense of curiosity about how the universe, in its randomness, can produce something so visually striking. What's more, the boundary between the dark and light regions isn't smooth. It's abrupt, as if someone painted the moon in two different shades and then just stopped midway. That suddenness feels unnatural, disjointed, and it leaves an unsettled feeling, much like encountering something familiar but fundamentally different, a face that looks human but isn't. Then there's the equatorial ridge, perhaps the strangest feature of all. Stretching 1,300 kilometers around the moon's middle like an impossibly tall mountain range. This ridge rises 20 kilometers in some places, making it one of the most pronounced surface features in the solar system. It's a scar, a seam, something that looks out of place, almost as if Iapetus was pieced together. Theories about its formation range from Iapetus, once spinning rapidly, causing material to pile up at its equator, to the idea that it might be the remnants of a collapsed ring. Neither explanation fully satisfies the imagination. There's something unnerving about such a massive structure on such a small moon. It makes you think about forces we can barely comprehend, forces that can reshape entire worlds, leaving behind scars that speak of a violent, ancient past. What's also unsettling is how Iapetus orbits Saturn. It's far out compared to most of Saturn's other moons, isolated, as if it were an outcast or a relic from another time. Its orbit is also tilted, another clue that this moon might not have always been part of the system. You get the feeling that Iapetus was captured, not born in its place, pulled in by Saturn's gravity long after it had formed elsewhere. This moon's very presence in its distant orbit hints at a deeper, older history that predates Saturn's familiar family of moons, a fragment of something long lost to time. In that sense, Iapetus feels like a memory, a leftover from a part of the solar system's past that we don't fully understand. But despite its strange appearance and mysterious origins, there's something oddly human about Iapetus. It's a world marked by division and scars, yet it persists, balancing its contradictions. If you were standing on its surface, gazing out into the cold distance, you'd see Saturn, massive and looming, dominating the sky. Iapetus would feel like a place where you could contemplate the very idea of being small, of existing on the edge of something much larger, much more powerful. There's a haunting beauty in the contrast between the light and dark, between the smooth plains and jagged ridge, and in how, despite all its oddities, Iapetus remains a part of the complex dance of the solar system. It makes you reflect on how even the most fractured, isolated objects can be part of something greater, contributing to the larger whole in ways we are only beginning to understand. Nix and Hydra, two of Pluto's small moons, orbit far from the chaos of the inner solar system, quietly tracing their paths in the distant, frozen outskirts of our cosmic neighborhood. They are tiny, irregularly shaped worlds, barely registering on the cosmic scale, but their existence adds to the complexity of the Pluto system, which is anything but simple. What's strange is how these moons don't act like typical moons. Their orbits are chaotic, constantly shifting and wobbling, as though they're caught in a delicate, gravitational dance with Pluto and its larger moon, Charon. This chaotic motion makes it impossible to predict their exact positions far into the future. Imagine standing on one of these moons. If it were even possible to stand on something so small and oddly shaped, and watching the sky, you'd see a dizzying, ever-changing view as Nix or Hydra wobbles unpredictably through space. Nix is a bit of an enigma. It's slightly larger than Hydra, about 50 kilometers across, and it reflects a lot of sunlight, almost as much as a field of fresh snow. This bright, icy surface suggests it's made primarily of water ice, but its color is strange too. Some parts of it have a reddish hue. This tint raises questions about what kind of materials or processes could give Nix such a varied appearance. Maybe it's cosmic dust, or perhaps chemical reactions driven by the weak sunlight at the edge of the solar system. Either way, it feels like the moon is wearing the scars of its environment, tiny clues left behind by the forces that have shaped it over billions of years. Hydra, on the other hand, is slightly smaller but has a reflective surface similar to Nix. Hydra's brightness is intriguing because, in such a distant and cold region, you wouldn't expect such small bodies to remain so clean and reflective. It's almost as though something keeps refreshing their surfaces, sweeping them clean of cosmic dust. But there's no clear answer as to how this happens. This reflects a larger theme of the outer solar system. Things don't always behave the way we expect. Hydra's elongated shape also gives it a strange, lumpy appearance. It's less like the moons we're used to seeing and more like a jagged piece of debris that somehow got pulled into Pluto's orbit. Perhaps what's most mind-bending about Nix and Hydra is how they interact with Pluto and Charon. Unlike Earth's moon, which is locked in a predictable orbit, these moons tumble in an unpredictable, almost wild manner, influenced by the gravitational pull of both Pluto and Charon. The Pluto system feels less like a hierarchy of one planet and its moons, and more like a complex system where everything pulls on everything else, creating chaotic, interwoven paths. Nix and Hydra are part of this web, their orbits shaped by the combined gravitational tug of Pluto and Charon, which behave almost like a double-planet system rather than a planet and its satellite. It's hard to wrap your mind around such a system, where nothing is fixed or stable, and yet it persists, with these small moons continuing their unpredictable motion through the cold and dark. What also adds to the strangeness is the idea that Nix and Hydra, along with Pluto's other small moons, Styx and Kerberos, were likely born from a violent past. The leading theory is that a long-ago collision between Pluto and another large body created these moons from the scattered debris. If that's true, then Nix and Hydra are remnants of a cataclysm, fragments of something much larger, now reduced to icy rubble orbiting in silence. They're survivors, in a way, carrying the history of that impact in their very existence. It's a reminder of how chaotic and violent the early solar system was, where planets and moons were constantly being reshaped by collisions, and yet out of that chaos, new worlds emerged. Standing on Nix or Hydra would be a surreal experience. Pluto and Charon would dominate the sky, filling it with their strange, contrasting forms. The stars would seem motionless by comparison, a backdrop to the restless, shifting ballet of these moons. It would feel like being in a place where time moves differently, where the laws of motion aren't quite the same as on Earth. In the distance, the sun would be a faint, distant point of light, so far away that its warmth feels almost imaginary. It's in that cold, distant region of space where Nix and Hydra continue their unpredictable journey, tiny, icy worlds that challenge our understanding of what a moon should be and how it should behave. They remind us that even in the most remote corners of the solar system, there's complexity, unpredictability, and a quiet, haunting beauty. Oberon and Titania, the two largest moons of Uranus, orbit in the distant and cold reaches of the solar system, far removed from the warmth and light of the sun. There's something eerie about how little we know about them, given their size and prominence around Uranus. Titania, the largest, is just over 1,500 kilometers across, about half the size of Earth's moon. Yet it's so far away that it remains a barely explored mystery. Oberon, not much smaller, is equally enigmatic, both moons holding secrets that we've only glimpsed through the blurry lens of a distant Voyager flyby. It feels almost absurd that such large moons exist in the shadow of Uranus, orbiting in near darkness, largely overlooked in the grand narrative of the solar system's exploration. Titania's surface is a haunting mixture of ancient craters and deep, dramatic fault lines that hint at some past tectonic activity. The sight of these enormous canyons, some stretching hundreds of kilometers, makes you think about the powerful forces that must have once shaken this moon. It's as if Titania tried to reshape itself, but then froze in time, locked in the deep cold of the outer solar system. Standing on one of those canyons, you'd be gazing across a vast, frozen rift, knowing that the ground beneath you once tried to pull apart. The surface is old, cratered, and worn. Yet those tectonic scars suggest a younger, more dynamic history lurking just beneath the icy crust. It's strange to think that even here, so far from the sun, where everything seems dead and still, there were once forces strong enough to create these massive features. Oberon, on the other hand, feels more isolated, its surface darker and even more cratered than Titania's. It's as if Oberon is a lonelier world, pockmarked and silent, left to its own devices for eons. One of the most striking features on Oberon is its sheer number of large craters, each a mark of violent impacts that occurred billions of years ago. Yet amidst all this evidence of destruction, there's something unsettlingly peaceful about it too. Frozen in time, unchanging, like a relic of the early solar system. It feels almost as though Oberon has been abandoned, its surface untouched since those ancient collisions. It's a stark reminder of the immense age of these moons, how they have witnessed the rise and fall of so much in the solar system while remaining virtually unchanged. The real mind-bending aspect of both Oberon and Titania lies in their orbits around Uranus. Uranus itself spins on its side, tilted at nearly 98 degrees, meaning its moons, including these two giants, orbit along this strange, horizontal plane. If you were standing on the surface of Titania, you wouldn't experience day and night in any normal sense. The sun would rise and set in strange, long arcs across the sky, with seasons that stretch for decades. When Uranus's poles faced the sun, one side of the moon would be bathed in continuous sunlight for years, while the other remains in perpetual darkness. This creates an alien sense of time. Time as we understand it on Earth would be irrelevant here. There's something deeply disorienting about the thought of living under those conditions, where the concept of night and day blurs into something completely unrecognizable. The possibility of subsurface oceans adds another layer of mystery. Some scientists speculate that beneath the thick, icy crust of Titania, there could be an ocean of liquid water, kept warm by the heat generated from radioactive decay deep within the moon. If that's true, Titania might not be as dead as it appears on the surface. It's a wild thought. This frozen, cratered world, so far from the sun, could harbor the conditions for life, buried beneath kilometers of ice. If there is an ocean, it would be a place of unimaginable darkness, where alien chemistry might be unfolding, completely isolated from the rest of the solar system. Oberon, too, might hold such secrets, though its thicker and more cratered surface makes it harder to imagine. What makes Oberon and Titania fascinating is their duality. On the surface, they seem frozen and inert, yet beneath the ice, they might hide entirely different stories. These moons remind us that even in the most desolate and distant corners of the solar system, there is always more than meets the eye. They challenge us to think beyond what we can immediately see, to imagine what could lie beneath the surface, and to consider the forces that have shaped them over billions of years. For all their stillness, there's a quiet energy to these worlds, a sense that they've seen far more of the solar system's history than we can comprehend, and they hold that history in silence, waiting for the day when we might finally uncover their secrets. Rhea, Saturn's second-largest moon, feels like a relic from another era, orbiting in the icy, far reaches of the planet's ring system. It's a world that appears simple at first glance, cold, barren, heavily cratered. But the more you learn about it, the stranger it becomes. There's an initial stillness to Rhea, its surface frozen and unchanging, but underneath that quiet exterior, there are puzzles that challenge what we think we know about moons in our solar system. One of the strangest aspects of Rhea is the possibility that it might have once had its own ring system, a miniature version of Saturn's iconic rings. While this idea remains speculative, some scientists have proposed that Rhea could be the first moon known to have rings. If true, it would make Rhea a curiosity unlike any other moon we've discovered. Though the evidence is elusive, hiding in the moon's faint gravitational pull. Imagine standing on Rhea's icy surface, surrounded by a landscape marked by impact craters, some so large they stretch across vast distances, giving you a sense of just how long this moon has been bombarded by debris from the early solar system. But what stands out is not just the craters. It's the difference between the two hemispheres. One side of Rhea is heavily cratered, scarred from countless impacts, while the other is smoother, as though it somehow managed to avoid the worst of cosmic violence. It's a contrast that raises questions about what kind of forces could have shaped the moon this way. Did Rhea once experience some cataclysmic event that resurfaced part of it, or has it somehow shielded one side from the solar system's constant bombardment? You can almost feel the tension in this landscape, a frozen world torn between its ancient scars and its more pristine, untouched regions. But it's not just Rhea's surface that raises questions. Deep below the ice, there may be something even more intriguing. Some scientists believe there's a possibility, however slim, that Rhea could have a subsurface ocean, much like its neighboring moons Enceladus or Europa. The idea that a moon so far from the sun, locked in the icy grip of Saturn's gravity, could harbor liquid water feels almost like science fiction. If such an ocean exists, it would be hidden beneath kilometers of ice, in total darkness, and completely isolated from the surface. This raises the tantalizing possibility that even on a world as seemingly dead as Rhea, there could be warmth and perhaps even the conditions necessary for life. The thought of an ocean under that frozen surface feels surreal. An entire ecosystem, if it exists, sealed off from the rest of the universe, evolving in its own quiet, unknowable way. And then there's the magnetosphere. Rhea's interaction with Saturn's magnetic field is another puzzle. The moon seems to generate an odd distortion in the field as it orbits the planet, and some scientists have wondered if this could be tied to the long-gone rings or something even stranger. Rhea's weak, almost ghostly magnetic signature raises questions about what might lie beneath the surface. Whether it's something geologically active or something entirely different that we haven't yet considered. Being this far from the sun, in the shadow of Saturn's vast presence, means we've only scratched the surface of what Rhea might be hiding. Rhea, like many moons in the outer solar system, forces us to think differently about what it means to be alive in a cosmic sense. It doesn't have the dramatic geysers of Enceladus or the thick, hazy atmosphere of Titan, but there's a quiet intrigue in its stillness. The possibility of hidden rings, or a subsurface ocean, or the odd interactions with Saturn's magnetic field. Each element feels like a thread in a larger mystery. Standing there, gazing at Saturn hanging in the sky, you'd be struck by the sense of time. How slowly things change on Rhea, how ancient it feels, yet how much remains unknown. It's a reminder that even in the coldest, most distant parts of the solar system, where everything seems frozen in place, there are secrets waiting to be uncovered, and maybe even things that defy the boundaries of what we think is possible. Proteus is one of those moons that seems to exist just beyond our understanding. A shadowy figure orbiting Neptune, shrouded in darkness and silence. It's irregular in shape, more like a jagged asteroid than the smooth, round moons we're used to imagining. Proteus is so dark that it barely reflects any light at all. It's like it's hiding, camouflaged against the blackness of space. The surface is heavily cratered, rough and uneven, as if it's been battered by the universe for billions of years without any chance to heal. There's something unsettling about how little we see, how little we know of this moon. Its surface is as black as coal, suggesting it's made of ancient materials, unchanged and untouched, remnants of the early solar system that have been drifting in the cold reaches around Neptune. What's truly bizarre is how close Proteus orbits to Neptune. It hovers just above the planet's cloud tops, skimming so close that you might think it would eventually spiral inward and crash into the gas giant. But Proteus is stable for now, locked in this tight orbit, circling Neptune in a kind of delicate balance. It's a reminder of how thin the line is between stability and chaos in space. At just the right distance, a moon can survive for billions of years, but one wrong move, one subtle shift in gravitational forces, and Proteus could be lost forever. That delicate tension feels almost palpable, as if the moon is walking a tightrope, always on the verge of something catastrophic. The fact that Proteus is irregularly shaped and so dark gives it an alien, almost ghostly presence. It doesn't look or behave like a typical moon, and in a way, it almost feels out of place, as if it's been captured by Neptune's gravity rather than born alongside the planet. Its odd shape suggests that it wasn't large enough to pull itself into a perfect sphere, a cosmic reminder of its size and limits. You can almost imagine Proteus wandering the outer solar system before Neptune pulled it into orbit, trapping it in this perpetual dance. There's a sense of isolation to it too. Despite being one of Neptune's moons, it feels distant, as though it's always existed on the fringes, never fully integrated into Neptune's complex system. What adds to the intrigue is how little light Proteus gets. Being so far from the Sun, Neptune's moons exist in a perpetual twilight. Standing on Proteus, the Sun would appear as just a distant star, a tiny, faint pinprick of light. The cold would be unimaginable, and the silence, absolute. It's almost impossible for us to grasp the kind of desolation Proteus experiences, orbiting so far from any warmth or light, in a realm of constant night. And yet, it persists, as it has for billions of years, orbiting Neptune in near invisibility. It's a world where time stretches out, where nothing changes, and where the only light comes from the occasional flash of a distant star or the faint glow from Neptune's cloud tops. The craters on Proteus, some of which are massive relative to the moon's size, tell the story of violent impacts, of collisions that nearly tore it apart but never quite succeeded. One crater, Pharos, stands out in particular, a reminder of the brutal forces Proteus has endured. Yet despite this, Proteus remains intact, clinging to its existence. It's a moon that seems to have survived against all odds, battered but unbroken, constantly defying the forces that could easily tear it apart. What's even more puzzling is that Proteus wasn't discovered until 1989, when Voyager 2 flew by Neptune. Despite being one of the larger moons in Neptune's system, it's so dark and distant that it escaped detection until we were able to send a spacecraft out that far. There's something humbling in that realization, that even in our own solar system, there are large, significant objects we only just discovered. It makes you wonder how much more is out there, just beyond the edges of our sight, hidden in the dark, waiting to be found. Proteus feels like a reminder of the mysteries that still lie within our solar system, of the worlds we barely understand. It exists in near total darkness, orbiting a planet that itself remains largely unexplored. It's a place where silence and cold dominate, where time stretches out in ways that feel almost incomprehensible. Yet, despite its isolation and its distance from the Sun, Proteus is part of the intricate, delicate balance of Neptune's moon system. It's a world that challenges our perceptions of what a moon should be, and in doing so, it quietly demands our attention, reminding us that even in the deepest reaches of the solar system, there are stories waiting to be told. Mimas feels like a contradiction, a tiny, frozen moon of Saturn that shouldn't be as fascinating as it is, yet there's something about it that's hard to shake. When you first look at Mimas, what strikes you immediately is that giant crater, Herschel, dominating one hemisphere. It's impossible to miss, spanning almost a third of the moon's diameter. The sheer size of it feels out of proportion, as if some colossal force once slammed into Mimas with enough power to nearly destroy it. The fact that Mimas survived that impact is incredible on its own, but what's even more unsettling is imagining what that moment must have been like. If you stood there, the explosion of debris and ice would have been cataclysmic, leaving behind a crater so deep and wide that it gives Mimas its distinctive, almost unreal appearance. It's a scar that tells the story of the moon's survival, frozen in time. Yet Mimas is more than just this battered, cratered rock. The more we've learned about it, the more it seems to defy easy explanations. For instance, despite its icy surface and small size, there's evidence that something strange might be happening inside. Mimas's orbit around Saturn shows slight wobbles, or librations, that are hard to explain unless there's something more than just solid rock beneath its icy crust. Some scientists have speculated that Mimas could hide a subsurface ocean, something completely unexpected for a moon this small and cold. The idea that under its frozen, cratered shell lies a hidden ocean is hard to wrap your mind around. How could this unassuming moon, which seems so static and lifeless on the surface, be harboring liquid water below? If it's true, Mimas would join a growing list of moons, like Europa, Enceladus, and Ganymede, that challenge our understanding of where life might exist in the solar system. This possibility of an ocean adds a layer of complexity to Mimas that's hard to reconcile with its appearance. It's easy to see Mimas as just a frozen relic, a world where nothing changes, and yet, if there's liquid water beneath its surface, then it's a place where something dynamic is happening. It's a reminder that even the coldest, most distant moons might be more alive than we give them credit for. The forces at play inside Mimas, if they do exist, suggest that heat generated by tidal forces from Saturn's immense gravity could be keeping this ocean liquid, preventing it from freezing solid. This quiet, hidden activity beneath the surface makes Mimas feel like a puzzle that's only half solved. And then there's its place in Saturn's gravitational landscape. Mimas orbits close to Saturn, in a region where the planet's rings dominate the sky. From the surface of Mimas, Saturn would loom impossibly large, filling the sky in ways that are hard to imagine from Earth. Its proximity to Saturn also means that Mimas is in a delicate gravitational balance with the planet and its other moons. This gravitational interplay causes Mimas to influence the rings, particularly the gap known as the Cassini division. This small, icy moon, so seemingly insignificant, plays a critical role in shaping the structure of Saturn's rings, pulling at the particles with its gravity, helping to define where the gaps appear. Mimas is also colder than most moons we've studied, with surface temperatures so low that water exists in a state harder than rock. The frigid cold of this moon feels like a warning, a reminder that the outer solar system is a place where the laws of nature we take for granted on Earth are pushed to their extremes. The ice that covers Mimas isn't just frozen. It's ancient, undisturbed for eons, and this stillness adds to the sense of isolation. Yet for all the cold and quiet, there's that underlying hint that something else could be happening beneath, a hidden layer of warmth and activity that contradicts the moon's frozen surface. Standing on Mimas, with Saturn dominating the sky, you'd feel the immense pull of the planet, not just physically but emotionally. The quiet might seem eternal, but beneath your feet, deep under the ice, there could be currents moving, tides rising and falling in a hidden ocean. It's this contrast between appearance and reality, between the frozen and the dynamic, that makes Mimas so compelling. It's a moon that looks simple and barren but might hold one of the most profound surprises in the solar system, reminding us that even the smallest, most overlooked places can be full of unexpected wonders. Umbriel is a moon that seems cloaked in shadow, not just because it orbits Uranus far from the sun, but because it's covered in a surface so dark it absorbs almost all the light that hits it. There's an eerie quality to it, as if it's been hidden from view for billions of years, keeping its secrets tightly sealed beneath a layer of ancient, pitch-black material. This darkness, almost unnatural in its completeness, makes Umbriel one of the least reflective bodies in the solar system. Looking at it, you'd almost feel like you're gazing into the void itself, a world that refuses to give anything away. It's as if the moon is telling us that it has seen things, that it carries the weight of cosmic history, but it chooses to remain silent. What adds to Umbriel's strange, mysterious nature is the contrast between its surface and its bright, distant cousin Ariel, another of Uranus's moons. While Ariel is marked with bright fractures and valleys, Umbriel looks dull, covered in craters that tell the story of countless impacts over billions of years. Yet there's something unsettling about how undisturbed it all seems. Like Umbriel has been frozen in time, unchanging, while the rest of the solar system has moved on. It feels almost as if Umbriel has withdrawn into itself, content to sit quietly at the edge of Uranus's realm, observing but never participating. One of the most perplexing features of Umbriel is the Wunda crater, a strange, unusually bright ring at its center that stands out starkly against the moon's dark surface. This bright spot, like a cosmic eye, almost feels like it's watching. It's an oddity that defies easy explanation, as if the moon is harboring a secret beneath its shadowy exterior. The contrast of this single bright ring against the rest of the moon's darkness feels like a crack in the facade, a hint that there may be more beneath the surface than we understand. It raises questions. Was there an ancient volcanic event that caused this bright patch? Or is there something strange about the material that formed the crater itself? Whatever the answer, the Wunda crater only adds to Umbriel's enigmatic nature. Umbriel is cold, so cold that it's hard to imagine. Temperatures here are lower than anywhere we're familiar with on Earth, the surface locked in ice harder than stone. The chill seems eternal, unrelenting, and yet deep beneath the surface. Some scientists speculate there could be the faint heat of radioactive decay. The idea that even on this dark, frozen world there could be some source of warmth, however minuscule, is a reminder of the hidden activity that might exist in the most unexpected places. If there's heat, there's the possibility that Umbriel, like some of its neighbors, could hide a subsurface ocean. The thought of liquid water buried far below this dark and ancient landscape seems almost too strange to consider, and yet it's a possibility that cannot be ruled out. If such an ocean exists, it would be locked away from the rest of the universe, isolated in a way that's hard to imagine, but still full of potential. The isolation of Umbriel extends beyond just its cold, dark surface. Orbiting Uranus, a planet tilted on its side, the Moon experiences seasons that stretch on for decades. In its winter, Umbriel is plunged into darkness for years at a time, the sun disappearing from its sky completely. You can imagine standing there, under a starless black sky, with nothing but the distant shine of Uranus itself to break the darkness. Time would stretch out in a way that feels almost unbearable. Days, weeks, months, and years would blur into one long night. And when the sun finally does rise again, it would only be a distant, pale star, offering little warmth. The thought of experiencing such extreme, alien seasons is unsettling. It's as if time moves differently here, where the ordinary rhythm of day and night, of light and dark, is replaced by these long, overwhelming stretches of emptiness. Umbriel's place in Uranus's moon system is also curious. Despite its size, it's the third largest of Uranus's moons. It's often overshadowed by its brighter, more active neighbors. Yet, this quiet moon is just as much a part of the intricate gravitational dance that keeps the Uranian moons in check. It's caught in a delicate balance with its fellow moons, all influenced by Uranus's intense gravity. But unlike some of the other moons, which show signs of tectonic activity or resurfacing, Umbriel seems content to remain as it is, a dark, quiet presence orbiting silently in the depths of space. There's something about this stillness, this lack of apparent activity, that makes Umbriel feel almost ancient, as if it's seen the solar system change and evolve around it, while it remains the same, untouched and unchanging. And yet, despite its stillness, Umbriel is not without its mysteries. The moon challenges our understanding of what a world can be, defying easy categorization. Its darkness, its isolation, its strange bright crater, all suggest there's more to this moon than meets the eye. It feels like Umbriel is hiding something from us, something ancient and profound, buried beneath its cold, dark surface, waiting for the day when we finally take a closer look. Until then, Umbriel remains a quiet enigma, orbiting in the shadow of Uranus. A reminder that even in the darkest, most distant corners of the solar system, there are stories we have yet to uncover. Nereid drifts in its distant orbit around Neptune like a world forgotten, a moon that seems to be caught between the outer reaches of the solar system and the pull of its icy planet. Its orbit is one of the most unusual things about it, wildly eccentric, swinging Nereid from a close pass near Neptune to a point where it's nearly 7 times farther away. It's almost as if Nereid can't decide whether to remain a part of Neptune's system or escape altogether. This erratic path suggests a violent past, perhaps a chaotic encounter that knocked Nereid off a more stable orbit long ago, possibly when Neptune captured its largest moon, Triton. You can almost feel the forces that must have acted on Nereid, yanking it back and forth in its battle with gravity. There's something unsettling in imagining what it would be like to exist on a world with such a disjointed relationship to its planet. The sheer distance that Nereid covers in its orbit means that the view from its surface would change dramatically depending on where it is in relation to Neptune. At its closest, Neptune would loom large in the sky, an enormous blue giant, its thick atmosphere swirling in bands of storms and deep azure clouds. But when Nereid is at its farthest point, Neptune would shrink into the distance, becoming just a distant pale disk, barely distinguishable from the stars beyond. The sense of isolation at these far points of its orbit would be profound. You can imagine the silence and cold that would settle over Nereid as it drifts farther and farther from its planet, into the outer darkness where sunlight is weak and the temperature plunges to extremes we can barely comprehend. Nereid's surface itself is a mystery, as we've only caught glimpses of it from the Voyager 2 flyby in 1989. What we do know suggests that Nereid is icy, much like other moons of the outer planets, but its surface seems to lack any large features, like towering mountains or vast canyons. that we might expect on a world so battered by its erratic journey around Neptune. It's almost as if Nereid's surface has been smoothed over, perhaps by layers of frost or ice that have built up over time, masking the craters and ridges that must exist beneath. The very texture of Nereid is strange to think about. An icy shell covering a world that's constantly pulled and stretched by gravitational forces as it swings back and forth in its wild orbit. There's something deeply lonely about Nereid. Unlike Neptune's other moons, which are locked in tighter orbits, bound by gravity in more predictable patterns, Nereid feels adrift. It's a reminder of how delicate the balance of orbits can be, and how one event, one collision or close encounter, can send a moon into a path that feels more like exile than orbit. Yet, despite this sense of isolation, Nereid remains tethered to Neptune, never quite breaking free, always returning after its long, wandering circuit around the planet. It's a relationship that feels precarious, as though Nereid could be on the edge of being flung out into space at any moment, never to return. Nereid's extreme orbit also raises the question of how stable it really is. Is it slowly drifting closer to Neptune, being pulled inward by the planet's gravity? Or is it destined to be a permanent wanderer, never settling into a more regular orbit, always swinging between proximity and distance? The sheer unpredictability of it adds a layer of tension to the moon's existence. It's as if Nereid's future is uncertain, trapped in a cosmic limbo where its fate could change with one shift in the delicate gravitational forces that govern Neptune's moons. And yet, despite this wild path and distant existence, Nereid has captured the interest of scientists for what it could tell us about the early solar system. Its strange orbit suggests that Nereid may have once been part of a different system entirely, perhaps a wandering body that was captured by Neptune long ago. If so, Nereid's story might be even more dramatic than we realize. A tale of a rogue world, caught by a giant planet's gravity and forced into a new, chaotic orbit. This possibility gives Nereid an almost tragic sense, as if it's been wrenched away from whatever path it was once on and thrown into a new, unpredictable life. For now, Nereid remains a distant enigma, a moon that challenges our understanding of orbits, stability, and what it means to be a part of a planetary system. It's a reminder that even in the cold, far reaches of our solar system, nothing is as straightforward as it seems. Nereid's orbit may be erratic, its surface largely unseen, but it holds secrets about Neptune, about its own past, and about the chaotic forces that have shaped it. All we know is that Nereid continues its long, wandering journey around Neptune, a silent traveler in the dark, waiting for the day when we might finally understand its place in the grand story of our solar system. Styx and Kerberos, two of Pluto's smallest moons, are like faint whispers in the vast cosmic dark, orbiting far beyond our everyday reach. They almost feel like celestial secrets, rarely discussed yet holding stories that stretch beyond the cold numbers and scientific data. Imagine standing on a world so distant that sunlight is barely more than a dim glow, casting weak, ghostly shadows. These moons spin in silence, frozen in time, orbiting a planet once thought to be the last edge of our solar system. Their discovery was recent, which feels surprising when you think about the immensity of space exploration. Kerberos, with its dark and almost hidden nature, reminds us of how much we still don't know. Its surface reflects so little light, it seems more like a shadow than a moon, blending with the endless void around it. The contrast between Kerberos and its neighboring moons is striking. While others reflect more light, Kerberos lurks quietly, its origins and mysteries leaving scientists scratching their heads. What formed this dark body? Why does it behave differently, almost as if it doesn't belong? There's something deeply unsettling and fascinating about a moon that refuses to shine. It feels like a cosmic enigma, daring us to find answers. Styx, though brighter, isn't any less strange. It is so small, less than 10 miles across, that you could walk its entire surface in a day. But what would that feel like? Standing on the surface of such a tiny, icy moon, you'd be caught between the terrifying pull of Pluto and the overwhelming emptiness beyond. With no atmosphere and gravity so weak that a single jump could launch you far into space, the experience of being on Styx would be surreal, as though reality itself were fragile. It's a place where survival is a fleeting thought, and existence feels like a whisper in a howling storm. Both moons rotate chaotically, tumbling unpredictably in their orbits, a detail that mirrors their distant and strange existence. Unlike Earth's moon, which keeps a consistent face towards us, Styx and Kerberos seem unable to decide which way they want to face. Their motion is like a slow dance, where they twirl in ways that defy normal expectations, reminding us that chaos, even in the depths of space, can be strangely beautiful. Their unstable rotations reflect the untamed nature of Pluto's distant realm, where the rules that govern our more familiar planetary systems begin to break down, leaving us with more questions than answers. This chaotic motion makes you wonder about the laws of the universe itself, about why these moons dance the way they do, seemingly indifferent to the order we expect from celestial mechanics. There's a hint of rebellion in them, a quiet defiance of what should be normal. Perhaps the most mind-boggling thought is that we know so little about these moons, despite them being part of our solar system. It's a humbling reminder that the cosmos is vast beyond measure, that even the smallest objects like Styx and Kerberos can stir up our deepest curiosity. They're like fragments of an ancient mystery, pieces of a puzzle that feels bigger than we can ever comprehend. In thinking about them, you can't help but feel a deep connection, as if these distant, cold moons are somehow a reflection of humanity's desire to reach beyond the known and the familiar. They speak to the part of us that yearns for exploration, for meaning in places that seem far removed from life itself. Yet there they are, orbiting quietly, defying our understanding, asking us to dream a little deeper, think a little further. Their quiet existence in the distant reaches of our solar system is both humbling and inspiring, a reminder of how small we are and yet how boundless our curiosity can be. Tethys and Dione orbit Saturn like ancient, frozen sentinels, each with their own mysteries that challenge our understanding of what a moon can be. Standing on one of these icy worlds, you would feel the quiet weight of time pressing down, a silence that stretches for billions of years. Tethys, with its bright, reflective surface, gleams like a cold, lifeless jewel. But it's not just its icy glow that captures the imagination. The massive crater called Odysseus scars its surface, a feature so enormous that if something like it existed on Earth, it would stretch across continents. It's almost impossible to comprehend the violence that created this, a single impact powerful enough to deform an entire moon. You might wonder what that moment looked like, a cataclysm that shook Tethys to its core, yet now all that's left is a frozen relic, a record of something unimaginable. Tethys also bears the Ithaca Chasma, a rift that extends for hundreds of miles across its surface, as if the moon itself was once torn apart and then left to heal, scarred but still whole. The thought of something so solid being ripped open like that is almost eerie. It speaks to the forces at play in this distant world, forces we can only guess at, as if the very ground beneath your feet on Tethys has been through a slow, glacial torment. It's easy to get lost in those ideas, imagining the internal fractures and shifts of a moon that feels frozen in time, yet holds the marks of ancient upheavals. Dione, on the other hand, tells a different story, though no less haunting. Its surface is riddled with craters, but what stands out are the bright, wispy streaks that stretch across its surface like a celestial fingerprint. These strange features, first thought to be icy cliffs, turned out to be fractures where ice has bubbled up from within, reflecting sunlight like a trail of ghosts across its landscape. The idea that something beneath Dion's icy crust might once have been active sends shivers down the spine. Could there still be processes at work deep beneath, hidden from view, slowly reshaping the moon in ways we can't yet perceive? There's something unsettling and thrilling about the idea that a frozen, distant moon might not be as dead as it appears. What makes both Tethys and Dione even more mind-boggling is the way they interact with Saturn's immense gravity, as if the giant planet is both their creator and destroyer. Tidal forces pull at them, subtly altering their surfaces over time, shaping and reshaping them in a slow, unending cycle. Saturn itself looms in their skies, a massive presence that dominates everything around it. Imagine standing on the surface of Dione, looking up and seeing Saturn's rings stretch across the sky like a cosmic tapestry, their silent beauty reminding you of how small and fragile these moons are in comparison to the giant they orbit. It would be like witnessing a distant, unreachable grandeur, where beauty and destruction are inextricably linked. There's also something deeply mysterious about the possibility of subsurface oceans on Dione. Could there be water hiding beneath its icy shell? And if so, could life, in some strange, extreme form, exist there as well? The thought feels almost absurd at first, but then you remember that Europa, another icy moon, might harbor life in its hidden oceans. Why not Dione? The possibility, however remote, makes you rethink everything you thought you knew about moons, planets, and the conditions necessary for life. It's a thought that burrows deep into the imagination, refusing to let go. Tethys and Dione, though seemingly quiet and distant, are not just chunks of rock and ice. They are worlds in their own right, shaped by time, by violence, and by the ever-present force of Saturn's gravity. The fact that they remain so enigmatic, with so much still unknown, only adds to their allure. Their surfaces might seem cold and uninviting, but beneath that icy facade lies the potential for stories untold, for secrets still waiting to be uncovered. It's in the unknown, in the silence of these distant moons, that the human mind finds itself most engaged, always reaching for answers in places where answers seem out of reach. And yet, there they are, orbiting Saturn, ancient and mysterious, beckoning us to keep exploring. Ariel, one of Uranus's moons, drifts silently in the cold, tilted world of its parent planet, as if caught in a cosmic dream. To imagine standing on Ariel's surface is to face an overwhelming sense of isolation, where the sun is little more than a distant star, casting a weak, bluish light over an icy, frozen landscape. What's striking about Ariel is its appearance, marked by a strange fusion of craters, canyons, and vast plains. It's as if the moon itself can't decide what it wants to be. A frozen relic of the past or something more dynamic, shaped by hidden forces beneath the surface. Ariel's most mind-boggling feature is the sheer scale of its vast chasms, some of which stretch for hundreds of miles. These canyons, deeper than anything we know on Earth, seem to hint at a violent past, where internal forces once pushed and pulled at the moon's icy crust, cracking it open and leaving behind scars that defy our sense of scale. It's almost as if Ariel is a giant puzzle, with pieces shifting slowly over eons, creating a landscape that feels ancient yet not entirely frozen in time. The thought that some of these chasms might have been shaped by internal processes, maybe even ancient cryovolcanism, makes Ariel feel less like a dead world and more like one that still holds secrets beneath its icy surface. The idea of cryovolcanism itself is enough to send the imagination spinning. Instead of molten lava, these icy volcanoes could have erupted water, ammonia, or methane, spilling across the surface and freezing almost instantly in the near-absolute cold. The image of a world where eruptions are made of frozen liquids rather than fire is both unsettling and fascinating. It challenges everything we know about planetary geology, forcing us to reconsider what a dynamic moon might look like in the outer reaches of the solar system. Ariel might not have the fiery intensity of Earth's volcanoes, but the possibility of these frozen eruptions paints a picture of a world where life itself would need to operate under entirely different rules. What makes Ariel even more intriguing is its relatively young surface, at least by cosmic standards. While many moons in the solar system are battered by craters, Ariel's surface is smoother in some regions, indicating that something, whether it's internal activity or something else entirely, has been at work, resurfacing parts of the moon. It's strange to think about a world that far out, where temperatures are impossibly cold, still undergoing change. What could be driving it? The gravitational pull of Uranus? Some internal heat left over from Ariel's formation? Or perhaps a slow, almost imperceptible churning beneath the surface that we can only guess at? Then there's the idea that Ariel might harbor a subsurface ocean hidden beneath its icy crust. It's a notion that feels almost too wild to believe at first. But when you consider that similar moons like Europa and Enceladus might have oceans beneath their frozen surfaces, suddenly it doesn't seem so far-fetched. The thought of liquid water, something so essential to life as we know it, existing deep beneath Ariel's icy shell, feels like the start of a story we don't yet know how to tell. Could there be something more beneath that frozen exterior, waiting for us to discover it? The possibility of a hidden ocean in a place so distant and cold is both thrilling and disorienting, as it expands the definition of where life might potentially exist. Ariel's orbit around Uranus, like the planet itself, is a bit of an oddity. Uranus is tilted on its side, which means that Ariel, along with the other moons, orbits in a plane that's almost perpendicular to the rest of the solar system. It's as if Ariel exists in a world that has been tipped over, out of alignment with everything else, yet still continuing its slow, steady path around the gas giant. The sheer strangeness of this orbit adds to the feeling that Ariel doesn't quite fit into the usual patterns of the cosmos. It's a moon shaped by forces we're still trying to understand, influenced by a planet that seems to break the rules of planetary alignment. To think of Ariel is to think of a world frozen and isolated, yet quietly holding onto the potential for surprises we've yet to fully grasp. There's something about the distance, the cold, the tilted nature of its world that stirs a sense of awe. It feels like Ariel has been waiting, silently, for eons, almost daring us to come closer, to peel back the layers of ice and uncover the truth beneath. Hyperion, one of Saturn's moons, doesn't quite fit the mold of what you expect from a celestial body. Its appearance is otherworldly, like something carved out of chaos, a sponge-like shape riddled with deep craters and strange, sharp ridges. Imagine a place where the ground beneath you is uneven, unpredictable, almost like walking on the surface of a giant, frozen sea sponge. The moon's low density makes it so porous that it feels less like a solid object and more like a bizarre, airy structure suspended in space, as if it were never fully formed or solidified. What's even more striking about Hyperion is its chaotic rotation. Unlike most moons, which spin steadily and predictably, Hyperion tumbles erratically through space, never showing the same face to Saturn twice. It's as if the moon has been locked in a cosmic dance it can't control, constantly twisting and turning without any set pattern. Standing on its surface, you'd feel completely disoriented, with the ground shifting beneath you in ways that defy your sense of balance. It's unsettling to imagine being in a place where even the sky above you would never look the same from one moment to the next. No sense of stability, no predictable horizon. Just the constant spinning of a world trapped in its own strange rhythm. What really gets under your skin, though, is the idea that Hyperion's chaotic rotation could be the result of its interactions with other moons, particularly Titan. The gravitational pull of Saturn and its moons exerts a strange influence on Hyperion, pulling it in different directions, almost like the moon is caught in a cosmic tug-of-war. It's a reminder of how delicate and unpredictable the forces at work in space can be, where even a small shift in gravitational balance can send an entire moon spiraling into madness. This chaotic motion feels like a cosmic metaphor, a reminder that even the most rigid-seeming structures can be thrown into disarray by invisible forces we barely understand. Hyperion's surface is coated with a thick layer of dark, reddish material that absorbs sunlight, creating an eerie contrast with the bright ice beneath. The origin of this material is a mystery, adding another layer of intrigue to an already strange world. It's as though Hyperion has been stained by something alien, something that doesn't quite belong in Saturn's domain. The reddish material almost feels like a veil, hiding the true nature of the moon beneath it. What caused this strange discoloration? Was it the result of impacts with other objects in space, or did it form from some ancient process we can't yet explain? The surface of Hyperion feels like a mystery wrapped in layers of unknown history, each crater and ridge holding clues that we haven't yet deciphered. One of the most mind-boggling things about Hyperion is its low gravity. With such a porous structure, its gravitational pull is so weak that a single jump could send you floating off into space, with nothing to pull you back down. Imagine standing on the edge of one of its deep craters, peering into the dark abyss below, knowing that if you weren't careful, you could drift away into the endless void. The sheer strangeness of this moon, with its erratic spin and low gravity, makes it feel like a place that shouldn't exist, like something out of a dream or a science fiction story. It's a place where the laws of physics seem to bend, where what you expect from a moon is turned upside down. Hyperion's very existence challenges our understanding of how moons form and behave. It's not spherical like most moons, but irregular, as if it never fully settled into the shape dictated by gravity. It's as though Hyperion is defying the usual rules, standing apart from the more orderly moons of Saturn, with their smooth orbits and predictable rotations. Its irregular shape and chaotic behavior give it an almost rebellious quality, a reminder that the cosmos is full of surprises that don't always fit neatly into our categories. There's something deeply unsettling and mesmerizing about Hyperion, as if it's a cosmic anomaly, an object that exists on the edge of what we understand. It feels like a place that has been shaped by forces beyond our comprehension, a moon caught between order and chaos, spinning through space in a way that defies explanation. Its oddness, its unpredictability, its very strangeness all make Hyperion a place that both terrifies and fascinates, a reminder that the universe is far more complex and mysterious than we often realize. Pan orbits Saturn like a tiny, delicate sculpture, almost too strange to be real. If you were to see it up close, the first thing that would strike you is its odd shape. More like a flying saucer than a typical moon. It's not just a moon but a world with a ridge circling its equator, giving it a flattened, disc-like appearance. It looks as if Pan was molded from soft material, pulled outward by invisible hands to create this unique form. It's hard to believe something like this could exist in the vacuum of space. Yet there it is, orbiting quietly within the gap of Saturn's ring, a silent guardian keeping the ring's particles in place. Pan is a shepherd moon, tasked by gravity with the role of carving and maintaining the inky gap, a narrow division within Saturn's vast ring system. As it moves along its orbit, it sweeps up ring particles, creating this clean, sharp boundary that feels almost artificial in its precision. It's mind-boggling to think that this tiny moon, no more than 20 miles across, has the power to shape and maintain part of Saturn's rings, a structure hundreds of thousands of miles wide. In a way, Pan acts like a cosmic gardener, trimming the edges of the rings and ensuring that everything stays in its proper place. You get the sense that without Pan, the rings might spill over into chaos, becoming less orderly and less defined. What's really strange about Pan is that ridge around its equator, a feature that almost looks like a miniature version of the rings it patrols. Scientists believe it might have formed from material Pan gathered from Saturn's rings over time, slowly building up around its middle like a belt. This idea, that a moon could collect particles from its surroundings and reshape itself, is almost too bizarre to grasp. It's as if Pan is a living part of Saturn's ring system, constantly interacting with its environment, growing and changing as it gathers material. The idea of a moon literally wearing part of its planet's rings as an adornment is both strange and strangely beautiful, a reminder of the interconnectedness of everything in space. What makes Pan even more surreal is its location. Orbiting within Saturn's rings, it's constantly surrounded by a swirling sea of ice and rock, tiny particles that reflect sunlight and make the rings glow from a distance. Imagine standing on Pan's surface and looking up to see Saturn's rings stretching out in every direction, an endless river of light and shadow swirling above your head. The sensation of being in the middle of such a vast, dynamic system would be overwhelming. You'd feel both incredibly small and incredibly important, knowing that Pan itself plays a vital role in maintaining the delicate balance of Saturn's rings. Pan's orbit is almost perfectly aligned with Saturn's equator, and it moves with a quiet precision that feels almost unnatural. It's hard to shake the sense that Pan's path through space is carefully orchestrated, like it's following a plan laid out billions of years ago. And yet, despite this apparent order, there's something chaotic about the moon's history. How did it end up here, in this role, shaping the rings of Saturn? Was it always this way, or did Pan evolve into its current state over time, slowly accumulating material from the rings and altering its shape and function? The thought of Pan's influence on Saturn's rings stirs something deep, the realization that even the smallest objects in space can have an enormous impact on the structures around them. Pan is tiny compared to Saturn, but without it, the rings would look different, perhaps less defined, less structured. It's a reminder that in space, size doesn't always dictate importance. Pan, with its odd shape and quiet orbit, is a key player in one of the most iconic features of the solar system. It's a moon that, despite its small size, commands attention, influencing the very appearance of Saturn itself. There's a certain mystery to Pan that goes beyond its physical characteristics, its very existence, its strange, sculpted shape, its role as a shepherd of the rings. These things make you wonder about the forces that shaped not just Pan, but the entire Saturnian system. It's a small moon with a big role, quietly maintaining the balance of one of the most beautiful structures in the solar system, all while remaining an enigma, a tiny world that defies easy explanation. Atlas orbits Saturn like a fragile, otherworldly craft, its shape so improbable it feels as if it belongs more to the realm of dreams than to cold, hard reality. The first time you see Atlas, it's impossible not to be struck by its resemblance to a flying saucer. Its equatorial ridge so pronounced that the moon looks like it was shaped by some deliberate force. You can almost imagine running your hand over its smooth surface, feeling the gentle rise of that ridge as it sweeps around the entire moon, making it seem more like a manufactured object than a natural satellite. How could something like this exist in nature, you wonder? It seems like Atlas was sculpted, a piece of cosmic art adrift in Saturn's rings. The moon's proximity to Saturn's outer A-ring puts it in a position of quiet power. Just like Pan, Atlas is a shepherd moon, tasked with keeping the outer edges of Saturn's rings in check. It's strange to think of a moon only about 19 miles wide exerting such influence, subtly guiding the particles of ice and rock that make up Saturn's rings, ensuring they stay within their boundaries. From this vantage point, you'd witness Atlas quietly sculpting the cosmic environment around it, a silent artist shaping Saturn's most famous feature without fanfare. The thought that this small moon helps define one of the most iconic sights in the solar system, those vast, shining rings, is enough to make your head spin. It's a reminder that even the smallest forces in space play critical roles in maintaining order in the chaos. Atlas' surface is equally as strange as its shape, smooth and unblemished in ways that defy expectations. Most moons are pockmarked with craters, the scars of ancient collisions, but Atlas looks like it's been untouched by time, as if no object has dared to mar its flawless form. Perhaps this is because of its role as a shepherd moon, constantly sweeping away particles, or perhaps Atlas has simply been lucky, protected by the vastness of Saturn's rings. But looking at that unmarked surface, you can't help but feel a sense of unease, like you're staring at something too perfect, too untouched by the violence of the cosmos. And then there's that ridge. Where did it come from? Scientists suspect it's the result of ring material accumulating on the moon over time, slowly building up around its equator in a process that feels almost organic, like a pearl forming inside an oyster. It's a strange thought that Atlas could be growing, reshaping itself as it moves through Saturn's rings, its very form evolving because of its environment. The idea that a moon can change, can gather material and transform, adds a dynamic, almost living quality to Atlas, making it feel less like a static object and more like something still in the process of becoming. This ridge, so out of place in the context of what we expect from moons, seems to whisper of a past we don't yet understand, and a future that might continue to unfold. The orbit of Atlas itself is another marvel. Moving just beyond the edge of Saturn's A-ring, it's perched at a delicate balance between the planet's gravity and the pull of the rings. It schemes along Saturn's edge as if dancing on a knife's edge, with the rings shimmering below like an ocean of frozen light. It's easy to imagine standing on Atlas' surface, looking up to see Saturn's rings towering above you, stretching out into the distance, so close you could almost reach out and touch them. The sheer scale of Saturn's rings from such a vantage point would be overwhelming, a reminder of the vastness of the forces at work and how small Atlas, and by extension, you, truly are in comparison. And yet, despite this delicate balance, despite its small size and fragile appearance, Atlas has stood the test of time. Its shape, its role as a shepherd moon, and its flawless surface all combine to give the impression of a moon that's both ancient and untouchable, as if it's been carefully preserved by some unseen hand. You wonder how long Atlas has been in this role, guarding Saturn's rings, and whether it will continue to do so long after we are gone. There's a sense of quiet permanence to Atlas, a feeling that it exists on a different timeline than we do, unaffected by the things that govern our world. The strangeness of Atlas makes you question what else is out there, waiting to be discovered. If a moon can look like this, if it can defy the expectations of what a moon should be, then what other surprises are waiting for us in the far reaches of the solar system? Atlas is more than just a moon. It's a symbol of the universe's ability to surprise us, to create things that are beyond our wildest imaginings, things that make us rethink everything we thought we knew. In its silence and simplicity, Atlas challenges our understanding, inviting us to look closer, to question more, and to never assume that we've seen everything space has to offer. Epimetheus is one of those moons that feels like a puzzle, almost as if it's playing a trick on anyone trying to make sense of it. What makes it instantly baffling is its relationship with another moon, Janus. Unlike anything you'd expect from celestial bodies, these two moons share an orbit around Saturn. They don't crash into each other, nor do they tear each other apart with gravitational forces. Instead, every few years, they exchange places like a cosmic dance routine. One moon moves slightly farther from Saturn, while the other moves slightly closer, and then they switch, continuing their orbit as if nothing unusual happened. It's one of those situations that feels like it shouldn't work, but it does, leaving you marveling at the sheer intricacy of their relationship. They are in constant motion, bound to each other by forces that feel more like a carefully timed ballet than the usual chaos of space. The idea that two moons can share the same orbit without catastrophe, without even a hint of instability, challenges everything you assume about how objects move through space. There's something profoundly human in the way they interact, as if they've reached an unspoken agreement, each one giving the other room to move, understanding that their continued existence relies on cooperation. It's like two people navigating a narrow hallway, gracefully stepping aside to let the other pass. And yet, these are not conscious beings. They are lifeless rocks in space, somehow perfectly in sync with one another, creating a phenomenon that feels more like art than science. Epimetheus itself is far from a smooth, symmetrical moon. It's irregular and scarred, covered in craters that tell the story of countless impacts over billions of years. If you were standing on its surface, you'd feel the history of the solar system beneath your feet. Every ridge, every depression marking a moment when Epimetheus was struck by debris. It feels ancient in a way that's hard to describe, as if it has seen more than it lets on. Its uneven surface adds to the mystery, making you wonder what forces shaped it, what collisions and near misses have defined its existence. The craters are deep, jagged reminders that space is not kind, that survival is a matter of enduring the onslaught of time and impact. But for all its ruggedness, Epimetheus also exists in this strange equilibrium, not just with Janus, but with Saturn's rings. It's close enough to feel their gravitational pull, yet far enough to remain apart from the swirling particles of ice and rock that make up Saturn's most famous feature. It's a delicate position, almost precarious, but Epimetheus holds its ground. It orbits just outside Saturn's F-ring, which itself is known for its unpredictability, a ring that seems to twist and bend as if it's alive. It's as if Epimetheus is watching from a distance, on the edge of something both beautiful and chaotic, maintaining a careful balance between order and disorder. What really makes Epimetheus stand out is its quiet resilience. It doesn't command attention in the way some of Saturn's more prominent moons do. It doesn't have the striking features of Titan or the icy geysers of Enceladus. And yet, Epimetheus has found a way to exist in a place where existence itself seems unlikely. Its shared orbit with Janus, its jagged, irregular shape, its place on the fringes of Saturn's rings. All these things make it feel like it shouldn't be here. And yet here it is, orbiting quietly, year after year, century after century. There's something inspiring about that, about the way Epimetheus endures, not through grandeur or spectacle but through quiet persistence. The more you think about Epimetheus, the more you realize that it represents something bigger than itself. It's a moon that defies expectations, one that makes you reconsider what's possible in space. If two moons can share an orbit, if a jagged, irregular object can carve out a stable existence in the chaotic environment around Saturn, then what else is possible? Epimetheus feels like a reminder that the universe is full of surprises, that there are forces at work we don't yet fully understand, but that nevertheless shape everything around us. It's a moon that, in its quiet, unassuming way, invites us to look closer, to question more deeply, and to never take anything in space for granted. Janus exists in a kind of celestial paradox, where it defies the natural instinct we have about orbits and motion. Imagine two moons sharing the same path around a planet, and rather than colliding in a cataclysmic event, they simply switch places every few years. That's Janus and its twin Epimetheus, locked in a gravitational waltz that's so precise it almost feels deliberate. The idea of two moons avoiding collision while traveling the same orbit is the sort of thing that makes you pause. How is it that the universe has arranged this delicate dance? It feels like something out of a story, where two entities are forever bound to switch places but never meet head-on. And yet, it's real. A reminder that nature doesn't always follow the simple rules we lay out for it. There's a strange comfort in that unpredictability, knowing that even in the vast emptiness of space, oddities like Janus exist. Janus itself is not a perfectly round moon but a lumpy, irregular body that speaks to its violent past. Every crater and groove tells a tale of ancient impacts, of times when it wasn't just switching places with Epimetheus, but colliding with the debris that floats through the Saturnian system. Standing on its surface, you'd feel like you were walking through the wreckage of a forgotten battlefield, where every scar on the landscape whispers of moments long gone. The jaggedness of Janus, its uneven shape, makes it feel untamed, wild, as though it's barely managed to hold itself together through all those collisions and impacts. And yet, despite its roughness, Janus has this almost mystical ability to maintain stability in its orbit, a feat that seems impossible when you first think about it. You imagine the gravitational forces tugging at it, Saturn's immense pull, the nudges from the nearby rings, the gentle push and pull between Janus and Epimetheus as they dance around their shared path. It feels like it should all come undone, like there's too much chaos at play for something so fragile to stay intact. But Janus endures, quietly riding the edge of Saturn's rings like a sentinel, watching over the delicate structures of ice and rock that make up the planet's most iconic feature. There's also a surreal sense of isolation about Janus. Even though it shares its orbit with Epimetheus, the two moons are never quite close enough to touch, never quite close enough to collide. It's a relationship of distance, a perfect metaphor for the way things can exist in parallel, influencing one another without ever fully merging. The moments when Janus and Epimetheus trade places are the closest they ever come to true interaction, and even then, it's fleeting, an almost ghostly exchange. This constant near-miss, the way they perpetually avoid catastrophe, feels deeply symbolic, as if it's trying to teach us something about coexistence, about balance. The thought of standing on Janus and looking up at the sky is something that pulls at your imagination. You'd see Saturn's rings looming above you, massive and brilliant. And yet there's the knowledge that Epimetheus is there too, somewhere, following the same path, just out of sight. It's a quiet kind of companionship, knowing that the other moon is there, orbiting along the same invisible track, even if you can't see it. And when they do finally switch places, there's almost a feeling of inevitability, as if the universe is simply resetting something ancient, something fundamental. What's most striking about Janus is how its existence forces you to rethink what's possible. The idea that two moons can share an orbit, avoiding the destruction we'd expect, makes you wonder what other impossible things are out there, waiting to be discovered. It's as if Janus is proof that the universe holds far more mysteries than we could ever hope to solve, that it's full of systems and relationships that don't fit neatly into our theories or models. There's something profound in that uncertainty, in the way Janus quietly defies our expectations while continuing its dance through space. It feels like a reminder that the cosmos is far more complex, far more interconnected than we often give it credit for, and that the mysteries we uncover will always lead to more questions than answers. Métis, one of Jupiter's innermost moons, exists in a place that feels almost perilous. It orbits so close to the planet that it practically brushes against Jupiter's outermost cloud layers. Just the thought of being so near to a gas giant that could swallow it whole if gravity decided to play a different hand is staggering. Métis sits right inside Jupiter's main ring, and it's believed that this little moon plays a part in maintaining the ring itself. You can imagine it, perpetually circling this titanic planet, contributing to the very structure that surrounds it, a role both delicate and profound. The proximity to Jupiter is mind-boggling, and the forces at play are nearly unimaginable. The immense gravitational pull of Jupiter should, by all logic, tear this moon apart, and yet Métis holds on, clinging to its fragile orbit, maintaining its strange little existence in the shadows of a cosmic giant. The way Métis interacts with Jupiter's rings makes you wonder about its nature. It's like the moon is part of a larger, invisible mechanism that we don't fully understand. As it orbits within the ring, Métis sheds tiny particles, possibly helping to replenish the ring's material. It's almost like the moon is dissolving into the ring over time, slowly giving pieces of itself to the great band of dust and ice. And in that act, Métis isn't just surviving. It's contributing to something bigger, becoming part of the very system it revolves within. The idea of a moon that is both part of the planet's rings and potentially shaped by those same rings is the kind of paradox that leaves you in awe of the universe's complexity. It's as if Métis is both an actor and an artifact of Jupiter's gravitational power, a fragile link in the chain of forces that make up the massive system of the gas giant. But then there's the speed. Métis moves fast, faster than Jupiter rotates. This means that, If you were standing on the surface of Jupiter and could somehow see Métis, it would be racing through the sky, overtaking the planet's own rotation. You'd be watching a moon that defies the normal rhythm of celestial mechanics, speeding along its orbit faster than the very planet it circles spins on its axis. This creates a strange feeling, as though time itself moves differently in Métis' world. It's not just the speed of its orbit that's astonishing, but the fact that it moves through space with such urgency, as if it's constantly trying to escape something. And yet, it can't escape Jupiter's pull. No matter how fast Métis moves, it's locked in this tight, gravitational dance with the planet. You start to think about what that means, about the raw power of a planet like Jupiter holding a moon so close that it's almost being pulled apart. The tidal forces alone must be immense. Jupiter's gravity constantly tugs at Métis, stretching it, warping it, and over time, these forces may very well tear it apart. There's something both awe-inspiring and tragic in that idea, as if Métis is fated to be destroyed by the very planet it orbits so closely. It's almost poetic in a way, the slow inevitability of destruction paired with the beauty of its role in Jupiter's ring system. The surface of Métis itself is a mystery. We've never seen it in detail, but you can imagine it being scarred and battered, shaped by constant impacts and the relentless gravitational forces pulling at it. It must be a lonely place, a world so close to Jupiter that it feels like it's on the edge of being consumed, yet still hanging on, orbit after orbit. The mind struggles to comprehend what it would feel like to stand on a world like that, with the massive bulk of Jupiter dominating the sky, filling your entire field of vision. You'd feel the weight of that presence, the sheer magnitude of a planet that dwarfs anything you've ever known. And yet, Métis continues its quiet, dizzying orbit, caught in a balance that feels both fragile and eternal. It's this contradiction, the idea that Métis is so near to both survival and destruction, that makes it so fascinating. Its existence feels improbable, almost like a temporary arrangement that could unravel at any moment. But for now, it endures, orbiting in the inner sanctum of the largest planet in our solar system, contributing to the vast, delicate beauty of Jupiter's rings. It's a moon that feels like it shouldn't be there, and yet it is, reminding us that the universe doesn't always play by the rules we expect. Adristia orbits so close to Jupiter that it almost feels as though it's clinging to the very edge of survival. It's the second closest of the planet's moons, circling just within the bounds of Jupiter's main ring. You can almost imagine it on the precipice, skimming just above the swirling clouds of the gas giant, pulled into a relentless orbit that keeps it trapped within Jupiter's massive gravitational influence. It moves so quickly around the planet that it completes one orbit in less than 8 hours, faster than Jupiter itself rotates. There's something unsettling in that image. A moon that outpaces the very planet it revolves around, always racing ahead, as if it's in a perpetual state of trying to stay just one step ahead of the crushing gravity below. Adristia's existence is intricately tied to Jupiter's rings, and in a way, it's one of the very sources of that delicate halo of dust and ice. It contributes material to the planet's rings, almost as if it's being slowly eroded away, losing pieces of itself as it continues its orbit. There's something haunting in that idea, a moon that's constantly sacrificing fragments of itself to maintain a structure as beautiful and fragile as Jupiter's rings. The rings themselves seem almost ethereal, and to think that Adristia is part of their origin adds a kind of vulnerability to the moon's existence. It's as though it's dissolving over time, bit by bit, contributing to something larger and more enduring, even as its own future seems uncertain. The forces acting on Adristia are staggering. Being so close to Jupiter means it's subjected to immense tidal forces, forces that stretch and compress the moon as it moves through its orbit. It's not just the pull of gravity that's shaping Adristia. It's the constant distortion of its structure, the way the planet is almost pulling it apart with every passing moment. Over time, you wonder how long such a small moon can withstand those forces. There's a sense of inevitability to its fate, a creeping realization that the forces of nature may one day break it down entirely. But for now, Adristia continues to orbit, to hold itself together in the face of such overwhelming power. Standing on Adristia, if such a thing were possible, would be surreal beyond measure. Jupiter would fill the sky, a massive, swirling presence that dominates everything, and the feeling of being so close to something so immense would be overwhelming. There would be no escaping the pull of Jupiter's gravity, the constant reminder that you are on a small, fragile body in the shadow of a titan. The surface itself would likely be rugged and pocked with craters, shaped by impacts from debris that gets drawn into Jupiter's orbit. Each crater would tell a story of survival, of the moon holding on despite the constant bombardment and the relentless tidal forces pulling at it. Adrastius' role in the larger system of Jupiter feels almost like that of a caretaker, quietly, almost imperceptibly, contributing to the beauty of the rings. The moon's small size and proximity to Jupiter make it easy to overlook, but without it, the system would be different. There's a kind of quiet resilience in the way Adrastea continues to exist in such a precarious orbit, continuing to contribute to the greater whole even as it faces the constant threat of being torn apart. It's a reminder that even the smallest bodies in the solar system can play a role in creating something breathtaking, that even in the face of overwhelming forces, there's a place for persistence and quiet contribution. The sheer improbability of Adrasteus' existence, so close to such an enormous planet, adds to the sense of wonder it inspires. It shouldn't be possible for something so small to survive in such an environment, to orbit so closely without being pulled apart by Jupiter's immense gravity. And yet, Adrastea endures, a quiet participant in the cosmic ballet of the Jovian system. It's a testament to the delicate balances that exist throughout the universe, where even the most fragile objects can survive against all odds, holding their place in a system that seems intent on breaking them down. The more you think about it, the more you realize that Adrasteus' very existence is an act of defiance. A moon that, against all expectations, continues its orbit around one of the most powerful forces in the solar system. Amalthea, one of Jupiter's moons, exists as a mystery, far removed from the grandeur of its larger siblings, yet brimming with its own enigma. Unlike the well-known Galilean moons, Amalthea doesn't draw attention with its size or scientific fame, but rather with its peculiar characteristics that make it feel more like a relic of ancient chaos. It's small, irregularly shaped, and a deep reddish hue, the kind of object that looks like it's been through the wars of cosmic history. Its odd form suggests it was never quite finished, like a fragment left over from something far bigger, or something that was shattered long ago, quietly drifting for eons until it found itself pulled into Jupiter's immense gravity. One of the most mind-bending aspects of Amalthea is its proximity to Jupiter itself. It's so close that the immense gas giant dominates its sky. Imagine standing on its jagged surface, the planet looming so impossibly large and overwhelming that you might feel as though the universe had swallowed you whole. The moon orbits within Jupiter's intense radiation belts, a place where the environment is relentlessly harsh, where radiation levels would shred human biology almost instantly. Yet somehow, Amalthea hangs there, frozen in its eternal dance, as though it has accepted the role of a cosmic survivor. Its surface is another riddle. Pockmarked by craters and grooves, it tells a story of violent impacts. The redness? It's thought to be the result of sulfur dust from Io, another of Jupiter's moons, that bombards Amalthea. Sulfur rains down from space, painting this tiny moon with the marks of its cosmic neighbors. A reminder that even in space, isolation is never absolute. The fine dust that covers Amalthea might seem inert, but it's evidence of a sort of cosmic interconnectedness, where even moons hundreds of thousands of miles apart can influence one another in unexpected ways. There's something unsettling about this, almost like a web of invisible threads binding these distant objects in a quiet, forceful exchange of matter. Then there's the question of how Amalthea came to be where it is. Did it form alongside Jupiter? Or was it something captured from elsewhere, drawn in by the immense gravitational force of the planet? Its irregular shape suggests it wasn't born in the same way the larger moons were. Instead, Amalthea might be a wanderer, pulled into the orbit of Jupiter from the far reaches of the solar system, an orphaned object that found a new home in a dangerous place. It's a haunting thought. A world once free, now eternally tethered to a force so massive it can never escape. Despite its small size and odd shape, Amalthea defies simple explanations. Scientists suspect that it might not be solid rock throughout. Its density is strangely low, leading to the speculation that it could be a porous body, full of gaps and voids, perhaps more fragile than it appears. It could crumble under the right conditions, a fragile relic of the solar system's violent early days. If you could peer inside, would it reveal ancient clues about the formation of the planets and moons? Or would it be emptier than expected, a void-filled shell with nothing but the echoes of ancient impacts to tell its story? Standing on Amalthea, looking at the overwhelming presence of Jupiter so close, might make you feel insignificant, as though the moon itself was a tiny pawn in a game of unimaginable scale. It's the kind of place that forces you to consider how small and fragile all things are when faced with the immensity of the cosmos. Himalaya orbits far from the chaotic intensity of Jupiter's closer moons, in a distant region that feels quiet in comparison. Yet that distance, that isolation, only adds to its strangeness. This small moon is part of a family of irregular satellites that don't quite fit into the neat, orderly system you might expect around such a giant planet. It orbits at a considerable distance, almost like an outcast, and its path around Jupiter is eccentric, tilted, and more inclined than the larger moons, giving it the appearance of something that wasn't meant to be there, as if it was pulled in from elsewhere. There's a deep mystery in this, a suggestion that Himalaya didn't originate with Jupiter, but instead was a rogue body, a leftover piece of some ancient cosmic puzzle. Himalaya's surface is a mystery in itself. While we haven't seen it up close, it's believed to be a rocky, irregular world, lacking the icy sheen you might expect from a moon so far from the sun. There's a subtlety in this, an unspoken question about its past. Did it once travel much closer to the sun, before being captured by Jupiter's gravity? Or was it always a wanderer, drifting aimlessly in the outer solar system before being claimed by this massive planet? Its rocky composition suggests that it has a story that stretches far back in time, a survivor from a forgotten era when the solar system was still forming, chaotic, and full of collisions. And yet, for all its distance, Himalaya is still within Jupiter's sphere of influence, its gravity holding it in place as it spins in a lonely, irregular orbit. There's something almost tragic in that. The idea that a body as small as Himalaya is forever bound to something so immense, so powerful. It's like being tethered to a force that is both protector and captor, never letting go, never letting you drift free again. That gravitational pull is a reminder of how things larger than us, more powerful than we can comprehend, quietly dictate the course of our lives, whether we notice or not. What's even more mind-boggling is the idea that Himalaya might have once been part of something larger. Some scientists think that it could be the remnant of a larger moon that was shattered long ago, possibly by a violent collision with another object. The pieces that remain, including Himalaya, are like fragments of a broken past, drifting in their orbits as quiet testaments to the violence that shaped them. If this is true, then standing on Himalaya might give you a sense of being on the ruins of a lost world, a ghostly remnant of something much grander, now reduced to rubble. It's haunting to think that a once whole body could be scattered like that, its existence now defined by absence and loss rather than anything solid. Yet for all this speculation, Himalaya remains elusive. We know so little about it that it's like a blank slate in our understanding of Jupiter's moons. It hides in the shadow of Jupiter's overwhelming presence, and maybe that's part of what makes it so fascinating. It's small, distant, and largely unexplored. But those very qualities make it feel like a world full of potential secrets. In that way, Himalaya feels like a symbol of the unknown, of all the things we haven't yet uncovered in our search to understand the cosmos. Despina is one of Neptune's moons, orbiting so close to the planet that it seems like it's caught in an impossible dance with destruction. The sheer proximity to Neptune means that this small, irregularly shaped moon is under constant gravitational stress, tugged and pulled by the planet's immense tidal forces. It's as though Despina is perpetually on the edge of being torn apart, clinging to an orbit that seems far too close for comfort. This gives it an eerie fragility, as if its very existence is a temporary state, destined to end when Neptune's gravity finally overwhelms it. The moon's proximity to Neptune also means it inhabits a realm of fierce and invisible forces. Neptune's rings lie just beyond Despina, and it's believed that this moon plays a role in shaping them. There's a certain poetry in that idea, a small, seemingly insignificant moon acting as a cosmic sculptor, controlling the debris that forms Neptune's faint, ethereal rings. It's as if Despina, despite being relatively tiny and largely unknown, exerts an influence far beyond what you'd expect. Its gravity, weak as it might be, has an outsized effect, helping to maintain order in the swirling chaos of dust and ice surrounding Neptune. But this influence is a double-edged sword. Despina itself is doomed. It's gradually spiraling inward, closer and closer to Neptune. In time, it will either be torn apart by the planet's gravity, adding to the rings it once shaped, or it will crash into Neptune's atmosphere, disintegrating in a final, violent plunge. This fate makes Despina a kind of cosmic tragic figure, caught in a slow, inevitable collapse, shaping its surroundings even as it moves toward its own destruction. It's a reminder that even in space, where things seem so vast and permanent, nothing lasts forever, not even moons. The surface of Despina is a landscape we can only imagine, as no spacecraft has yet visited it in detail. But considering its location, it's likely a barren, cratered world, sculpted by impacts over millennia, its surface bathed in the cold, faint sunlight of the outer solar system. There's something isolating in the thought of such a world, a place so distant from the warmth and light that life as we know it depends on. Despina is locked in Neptune's shadow, far from the sun, in a region of space that feels almost forgotten, frozen in time and space. What makes Despina so mind-boggling isn't just its proximity to Neptune or its doomed orbit. It's the sense of scale, the way this small, irregular moon fits into the vast mechanics of the solar system. It plays a role in shaping the rings of a giant planet, yet its own fate is sealed by forces it cannot escape. There's an almost haunting beauty in that balance, in the way something so small and remote can still exert influence, even as it succumbs to forces far beyond its control. Larissa, another of Neptune's moons, exists in a delicate balance between survival and collapse, orbiting dangerously close to the planet's powerful gravity. It's a small and irregular moon, shaped more like a fragment than a full-fledged world, and that's part of its mystery. Larissa's jagged surface suggests a violent past, as if it's been pieced together by collisions and cosmic impacts over millions of years. Its form a patchwork of old scars. There's something haunting in that. The idea that this tiny moon has witnessed unimaginable forces, bearing the marks of an ancient and chaotic history. Being so close to Neptune, Larissa inhabits a zone where the tidal forces are constantly pulling at it, as if trying to pull it apart. The moon seems almost fragile in this environment, with its irregular shape a testament to its battle against these enormous forces. In some ways, Larissa feels like it's on borrowed time, much like its neighbor Despina. Over time, Neptune's gravity will drag it inward, likely causing it to break apart or spiral into the planet itself. It's a fate that's already written, a slow march toward destruction that Larissa can't escape. This inevitability gives the moon an air of melancholy, a small object quietly awaiting its end in the immense shadow of Neptune. There's an odd beauty in Larissa's current role in Neptune's system. Even as it's fated to be destroyed, it still plays a part in maintaining the structure of Neptune's rings. Its gravity helps shepherd the particles that make up these delicate, faint rings, keeping them in line as they orbit the planet. It's almost as if Larissa is performing one last duty before its eventual demise, contributing to the planet's overall system in a way that feels both subtle and crucial. It's mind-boggling to think that such a small and seemingly insignificant moon can play a role in something so grand, acting as a quiet guardian of Neptune's rings even as it succumbs to the forces around it. The thought of standing on Larissa, looking out at Neptune, is an unsettling one. The planet would dominate the sky, its massive bulk filling your vision, a constant reminder of the moon's precarious position. The surface beneath you would likely be rough, barren, a place shaped by impacts and forces beyond our imagination. There's no atmosphere here, no protection from the harshness of space, just the cold, endless void and the overwhelming presence of Neptune pulling at you. The isolation of Larissa in this distant region of the solar system feels almost complete, a world on the edge, both figuratively and literally. One of the most perplexing aspects of Larissa is how little we truly know about it. We've only glimpsed it from afar, and yet it hints at stories of destruction, survival, and cosmic forces at play on scales we can barely comprehend. It's a moon that feels forgotten in many ways, overshadowed by larger objects in the solar system, and yet it holds within it the quiet, mind-bending reality of all things destined to fall apart under the weight of forces they cannot resist. Its orbit, its shape, its fate. All of these things remind us of the delicate balance that governs the universe, a balance in which even the smallest of moons can have an impact before they are inevitably claimed by something larger and more powerful. Galatea orbits Neptune in a way that feels almost too close for comfort, locked in a gravitational grip that seems to pull it toward the planet, yet somehow it remains intact. What makes Galatea so fascinating is not just its proximity, but the quiet and almost invisible influence it has on Neptune's rings. It's a shepherd moon, a small and irregular body that helps maintain the delicate structure of Neptune's narrow Adam's ring. This moon exerts its influence like an unseen force, keeping the particles of the ring in check as they whirl around the planet. The thought of such a tiny, insignificant object controlling something as vast and dynamic as a planetary ring is mind-boggling in itself. A cosmic reminder that small things can wield surprising power. What's even more intriguing is how precarious Galatea's existence really is. It's trapped in an orbit so close to Neptune that it feels like it's constantly on the verge of being pulled apart. Neptune's gravity tugs at the moon relentlessly, warping and shaping it over time. Yet Galatea holds on, as if refusing to succumb to the overwhelming forces around it. There's something almost stubborn in this, as though the moon is clinging to its role in the system, maintaining order in the chaos of Neptune's ring system even as it teeters on the edge of destruction. Galatea's surface, though we haven't seen it in detail, likely mirrors this struggle. It's probably pockmarked by impacts, its irregular shape hinting at the violence of its past. Unlike the larger, more well-known moons of Neptune, Galatea feels more like a survivor, a fragment left over from an earlier time, perhaps a remnant of something larger that was shattered long ago. This sense of fragility, of being a leftover piece in a cosmic puzzle, gives Galatea a certain melancholic air. It exists in a state of tension, always pulled between survival and destruction, with no clear end in sight. There's also something deeply strange about Galatea's role as a shepherd moon. It's not just that it controls the Adam's ring. It's how precise that control seems to be. The moon's gravity doesn't just keep the particles in the ring from drifting away, it actually creates a pattern within the ring itself. A series of arcs where the particles are denser, almost like stripes on the edge of Neptune's atmosphere. These arcs are an anomaly, a feature that defies simple explanation, and Galatea is at the heart of that mystery. How does such a small moon create such complex structures in something as vast and dynamic as a planetary ring? It's as if Galatea, in its quiet, unassuming way, has mastered the art of balance in a system that is otherwise dominated by chaos. In many ways, Galatea feels like a moon defined by contradictions. It's small, yet powerful enough to influence an entire ring system. It's fragile, yet it survives in one of the most hostile environments in the solar system. And it's locked in a perpetual struggle with Neptune's gravity, yet somehow manages to hold its place, shaping the space around it even as it faces the constant threat of being torn apart. This delicate dance between destruction and influence, between fragility and control, is what makes Galatea so fascinating. It's a reminder that the universe operates on scales and forces that are both incomprehensible and strangely intimate, where even the smallest of moons can alter the course of something far larger than itself. Puck orbits Uranus as a small, unassuming moon, but what makes it truly fascinating is its role in the crowded and complex environment around the planet. Puck sits in a region where it has to share space with Uranus' faint rings and a swarm of other moons, creating a delicate balancing act. In this crowded neighborhood, Puck is something of a survivor. Despite being just over 160 kilometers in diameter, it manages to maintain its orbit, threading its way through gravitational interactions and avoiding collisions in a realm where chaos feels just a small nudge away. The shape of Puck itself is curious, not quite spherical, but more like an irregular, cratered chunk of rock. It seems weathered, as though it's been battered by countless impacts over the eons. These craters are a reminder of the violence that still exists in the solar system, even at the far reaches of Uranus. Looking at Puck, it feels like you're seeing a relic from an ancient time, a small moon that has endured unimaginable cosmic forces and still holds itself together, scarred but stable. There's a rugged beauty in that, the way it wears its history on its surface, as though every crater tells a story of an impact, a collision, a near disaster that it somehow survived. Puck's proximity to Uranus also means it's under constant influence from the planet's gravity. This immense pull affects the moon's shape and orbit, but Puck seems to take it in stride, continuing on its path as though it's adapted to the forces at play around it. There's something resilient about that, a kind of quiet endurance in the face of overwhelming forces. It doesn't have the mass or size to push back against Uranus' gravity, but instead, it moves with it, in harmony, maintaining its fragile existence in a space where disruption is never far away. What makes Puck especially interesting is that it orbits within Uranus' strange tilt. The planet is tipped on its side compared to the rest of the solar system, and all of its moons, including Puck, follow that same unusual orientation. This tilt, caused by some ancient cataclysm, creates a surreal dynamic. Puck's orbit isn't just around a planet, it's part of a system that feels slightly out of place, as if the usual rules don't quite apply here. The moon moves in a tilted plane, under the influence of a tilted world, contributing to the overall strangeness of Uranus and its system. There's also the mystery of what Puck is made of. Like many of Uranus' moons, it's likely a mix of rock and ice, but we don't know for sure. It's a tantalizing puzzle, because if we could understand the composition of Puck, we might gain insight into the history of Uranus itself. Is Puck a remnant from the planet's formation, or was it captured later, dragged into Uranus' gravitational influence? Its rough surface and irregular shape hint at a long, tumultuous history, but there's still so much left unanswered about how this moon came to be where it is today. And then there's the simple fact that Puck is so far from the sun, existing in the cold, outer regions of the solar system. The sunlight here is faint, barely strong enough to cast shadows, and Puck spins in this distant twilight, endlessly circling Uranus in a place that feels forgotten by the rest of the solar system. It's easy to imagine Puck as a quiet observer, orbiting in the shadows of a distant world, aware of the immensity of space around it, yet somehow content to continue its lonely journey through the darkness, marked by the scars of the past but still whole. Sycorax orbits Uranus at a vast distance, far beyond the planet's major moons, in a realm that feels almost detached from the rest of the system. There's something haunting about the way this moon exists on the fringes, like a distant outpost in the depths of space. Its orbit is highly inclined and retrograde, meaning it moves in the opposite direction of Uranus' rotation, a clue that Sycorax didn't form alongside the planet. It's likely a captured object, pulled in from the distant edges of the solar system, a relic of a time when the outer planets were sweeping up leftover debris from the early days of planetary formation. This capture scenario gives Sycorax an air of mystery, as though it doesn't truly belong to Uranus, but was instead snatched from some forgotten corner of the universe, now bound to the planet in a slow, irregular dance. The distance at which Sycorax orbits is staggering. It's so far from Uranus that it barely feels like it's part of the same system, more like a visitor than a permanent resident. Out here, in the cold and dark, Sycorax is isolated, its surface bathed in faint sunlight that barely reaches it. There's something eerie about imagining what it would be like to stand on Sycorax, with Uranus only a tiny point of light in the sky, rather than the dominant presence it would be on the closer moons. Sycorax moves in this shadowed, outer region, a place where the normal dynamics of the solar system start to feel distant and abstract, and the vastness of space becomes more overwhelming. What makes Sycorax so compelling is the suggestion that it could be a remnant from the Kuiper Belt, a frozen world that once drifted far beyond Neptune before being pulled into Uranus orbit. Its retrograde motion and inclined orbit are signatures of a world that wasn't always part of this planetary system, and that opens up a whole realm of possibilities. If Sycorax is indeed a captured body, it could be made of ancient materials from the outer reaches of the solar system, untouched by the processes that shaped the inner planets. This could make it a kind of time capsule, preserving the conditions of the early solar system in a way that's been lost closer to the sun. The thought that Sycorax holds secrets about the formation of the solar system, locked away in its icy, distant landscape, is mind-boggling. It's like a piece of forgotten history quietly orbiting Uranus, waiting to reveal its past. There's also something fascinating about how little we know of Sycorax. It's a large moon compared to others around Uranus, but its great distance and faint visibility have kept it shrouded in mystery. We've only glimpsed it through telescopes, meaning its surface, composition, and history remain largely unknown. The very fact that Sycorax exists at the edge of our knowledge feels like an invitation to explore, to push beyond the familiar and see what lies further out. Its orbit alone suggests a story of capture, chaos, and survival, yet it offers so few clues, as if it's guarding its secrets. Being so far from Uranus also means that Sycorax experiences an almost ghostly existence, orbiting in the outer reaches of the planet's gravitational field where the pull of Uranus is weak, but still enough to keep it bound. This tenuous connection gives Sycorax an eerie, liminal quality. It's part of Uranus' system, but only just, like a moon that never fully committed to its new home. It's as though Sycorax exists on the border between belonging and drifting away, a strange and distant companion to a planet already known for its odd tilt and unusual dynamics. The isolation of Sycorax, combined with its mysterious origins, creates a sense that it's a moon out of place, a wanderer trapped in a system where it doesn't quite fit. And then there's the cold. Sycorax is so far from the sun that temperatures on its surface must be unimaginably frigid, colder than anything we can experience on Earth. It exists in a realm of permanent frost, where sunlight is a distant, barely present force. The ice and rock that make up Sycorax's surface are likely frozen solid, undisturbed for billions of years. In this frozen state, it feels like time has stopped, as though Sycorax is a moon frozen in history as much as in temperature. It drifts through the darkness, a frozen relic from another era, its secrets preserved in the ice, waiting for a future that may never come. Caliban is one of Uranus' outer moons, and its very existence seems like a cosmic riddle. Orbiting in the distant, cold reaches of Uranus' gravitational influence, Caliban feels like it belongs more to the vast emptiness of the outer solar system than to the planet itself. Its retrograde orbit, moving against the spin of Uranus, suggests that it's not a native moon but a captured object. There's something unsettling and intriguing about this. The idea that Caliban may have once drifted freely through the solar system, only to be caught by Uranus gravity at some point in the distant past. It feels like a moon with a story to tell, one that spans the chaotic early days of the solar system when planets and moons were still finding their places. The retrograde orbit is particularly striking because it hints at a violent past. To be captured by a planet like Uranus means that Caliban likely had a close encounter with either Uranus itself or another body in the solar system. It's easy to imagine this small moon being flung into Uranus' gravity well during some ancient gravitational shuffle, forever changing its trajectory. That same capture could have sealed its fate, locking Caliban into its strange, counterintuitive orbit. This gives it an air of rebellion, moving in the opposite direction from most of Uranus' moons, almost as if it's defying the norms of the planetary system it now calls home. Caliban's distance from Uranus adds to the sense that it's an outsider. It's far enough away that Uranus would appear as little more than a faint, distant globe in the sky, and the sun's light is so dim that the moon exists in a perpetual twilight. This distance, combined with its retrograde orbit, makes Caliban feel like it's only loosely connected to Uranus, more like a drifter on the outskirts of the system than a tightly bound satellite. It's a moon caught between worlds, not quite part of Uranus, yet no longer free to wander the solar system as it once might have. This liminal existence is fascinating, as it seems to mirror the chaotic forces that shape the outer solar system itself. Caliban's surface is still largely a mystery. Like its fellow distant moons, it hasn't been visited by spacecraft, and telescopic observations reveal only hints about its nature. It's likely a mixture of rock and ice, frozen solid in the extreme cold of its environment. There's something almost timeless about this frozen state, as though Caliban has been preserved in deep freeze since its capture, untouched by the geological activity that shapes larger, closer moons. This idea of Caliban as a frozen relic, a world suspended in time, is mind-boggling. It's as if the moon itself is a piece of history, a small, irregular body that holds within it the secrets of the early solar system, quietly orbiting Uranus in a dark, distant part of space. What's even more thought-provoking is the possibility that Caliban is not alone in its origins. It's part of a group of moons with similar orbits, including Sycorax, all of which are thought to have been captured at around the same time. This suggests that Caliban may have been part of a larger event, a capture scenario involving multiple bodies, perhaps remnants of a shattered object or debris left over from the formation of the outer solar system. The thought that Caliban's story might be tied to a larger, more complex history adds another layer of intrigue. It's not just a solitary wanderer, but part of a collective history of capture and survival, a piece of a puzzle we don't yet fully understand. And then there's the sheer remoteness of it. Caliban orbits so far from the warmth of the sun that its environment is nearly incomprehensible. The cold here is beyond anything we can truly imagine. A deep, unrelenting freeze that grips the moon and never lets go. This isolation, combined with its retrograde motion and possible capture, makes Caliban feel like a world that operates by its own rules, as if it's part of a story that we can only glimpse from afar. The mind-bending part of Caliban isn't just its orbit or its distant, frozen state, but the way it seems to sit on the edge of known and unknown, a small, icy world with a past that stretches back to the chaotic beginnings of the solar system, holding secrets we're only beginning to uncover. Hippocamp is a tiny moon orbiting Neptune, a recent discovery that feels almost like it slipped through the cracks of our understanding for so long. Its existence is surprising not just because of its size. It's incredibly small, only about 34 kilometers across, but because it orbits so close to much larger moons, especially Proteus, which seems like it should have prevented such a small body from forming or surviving in the first place. That's the first mind-boggling aspect of Hippocamp. How did something so tiny manage to exist in the gravitational chaos of Neptune's moon system, where larger bodies dominate? It's as though Hippocamp is a ghost, a fragile remnant left over from a time when the solar system was more chaotic and violent. There's a theory that Hippocamp is actually a fragment of Proteus, the much larger moon that orbits just a short distance away. Proteus itself bears the scars of a violent past, including a massive impact crater that seems like it almost shattered the moon. The idea is that this impact may have been so powerful that it blasted a chunk of Proteus into space, and that chunk eventually settled into its own orbit around Neptune, becoming Hippocamp. This possibility is staggering because it suggests that Hippocamp isn't a moon in the traditional sense, formed by the slow accumulation of dust and ice, but a piece of cosmic debris, a fragment of a larger world that has somehow survived for billions of years. It's like a shard of glass from a broken window, still orbiting alongside the very object that once contained it. This connection to Proteus adds an eerie sense of proximity to Hippocamp's existence. It's so close to the larger moon that it's hard to imagine it staying stable for long. In fact, there's something almost precarious about its orbit, as if it's locked in a delicate dance with the much more massive Proteus, caught between the gravitational pull of Neptune and its larger neighbor. It's a reminder of how fragile and dynamic these systems can be, where even small objects like Hippocamp can influence and be influenced by the giants nearby. The fact that Hippocamp hasn't been disrupted or absorbed by Proteus, or sent spiraling into Neptune, feels like a cosmic balancing act that defies easy explanation. The discovery of Hippocamp itself is fascinating. It was only found in 2013 through careful analysis of old images taken by the Hubble Space Telescope. This means that even in the modern era of space exploration, there are still moons, small and faint, hiding in plain sight around the planets we thought we knew so well. There's something humbling about that. The idea that such a close neighbor to Proteus could go unnoticed for so long, revealing just how much we still have to learn about the outer solar system. Hippocamp is a quiet reminder that the universe is filled with hidden things, waiting to be discovered, even in places we think we've already mapped. What's also intriguing is the name Hippocamp, after a mythical sea creature that was half horse, half fish. The choice of this name gives the moon a sense of whimsy, a nod to the deep, mysterious waters of Neptune, named after the Roman god of the sea. It feels appropriate given that Neptune's entire moon system is like an ocean of its own, filled with hidden currents and strange, unexplored regions. Hippocamp, with its small size and precarious orbit, is like a tiny creature darting through these cosmic waters, barely noticed, yet playing its own small role in the vast, swirling system that surrounds Neptune. There's also the question of what Hippocamp is made of. Its size and the likelihood that it was born from a violent impact make it probable that it's composed of the same materials as Proteus, a mixture of ice and rock, frozen solid in the cold reaches of Neptune's orbit. But what if there's something more to it? Its small size and close proximity to Neptune mean it could be affected by the planet's gravitational forces in ways we don't fully understand. There's the tantalizing possibility that Hippocamp might show us something new about how moons evolve and survive in the chaotic environments of the outer planets, especially in systems where large moons and rings can exert powerful forces on their smaller neighbors. Hippocamp's very existence challenges our understanding of how moons form, survive, and evolve in the harsh environment of the outer solar system. It feels like a mystery that we're only beginning to unravel, a tiny, fragile world that somehow thrives in the shadow of giants. Its proximity to Proteus, its likely violent origins, and the fact that it remained hidden for so long all add layers of intrigue. Even though it's one of the smallest moons we've discovered, Hippocamp carries a story that stretches back to the earliest days of the solar system, a fragment of a much larger tale that we're still piecing together. Kerberos, one of Pluto's smaller moons, feels like a ghost orbiting in the far reaches of the solar system. What makes Kerberos fascinating is how its discovery came as a surprise. Pluto already had its major companion, Charon, and two smaller moons, Nix and Hydra, but then Kerberos appeared, faint and elusive, hidden between its larger neighbors. This moon wasn't detected until 2011, and that alone is mind-boggling. That in a system we thought we knew, there was still something lurking in the darkness, waiting to be found. Its faintness makes it feel almost invisible, a shadowy presence that somehow managed to escape detection for so long, which makes you wonder what else might be out there, hidden in the farthest corners of the solar system, just out of view. Kerberos' size is another piece of the puzzle. It's small, even compared to Pluto's other moons, measuring only about 19 kilometers across. What makes this even more puzzling is that it has such a low albedo, meaning it's surprisingly dark for a body in this region. Its siblings, Nix and Hydra, are bright and reflect a lot of sunlight, but Kerberos seems to absorb more light than it reflects, making it stand out as the darkest of Pluto's moons. This contrast raises questions about its origin. Where did Kerberos come from, and why does it look so different from its neighboring moons? There's a theory that all of Pluto's moons, including Kerberos, formed from a massive collision, perhaps between Pluto and another large object early in the solar system's history. If that's true, then Kerberos is a fragment of that cataclysmic event, a piece of debris that somehow coalesced into a moon. But its dark surface suggests that it either formed from different material than the others, or something about its history has darkened it over time. This mystery makes Kerberos feel almost like an outsider within its own system, quietly orbiting Pluto, holding onto a secret about its past. The darkness of Kerberos also makes it feel eerie in a way. It's orbiting in a region that's already so far from the sun that light barely reaches it, and yet it absorbs what little light comes its way. It's as though Kerberos is cloaked in shadow, a moon that's more invisible than present, blending into the inky blackness of space. To think of standing on Kerberos, if such a thing were possible, would be to imagine a landscape so dark and cold that it would feel almost surreal. The sun, barely a bright star in the distance, would cast weak shadows, but the moon itself might feel more like a place where darkness reigns, where even the light can't seem to take hold. What's even more fascinating about Kerberos is the fact that its discovery came just a few years before New Horizons flew by Pluto. By the time we learned about this moon, we were already preparing to get our first real look at Pluto and its moons, and the timing feels almost serendipitous. When New Horizons reached Pluto in 2015, it provided us with the first glimpse of Kerberos, but even that didn't answer all of our questions. In fact, New Horizons only added to the mystery. The spacecraft revealed that Kerberos isn't just dark, but also has an unusual shape, with a double-lobed structure that suggests it may have formed from the merger of two smaller bodies. This raises even more questions. Did Kerberos form in place, or did it somehow come together from debris in the aftermath of a violent collision? The idea that Kerberos might be the result of two smaller moons coming together adds a layer of complexity to its already mysterious nature, making it feel like a moon that's been pieced together from the remnants of something older and more chaotic. Its orbit is another element that seems strange. Kerberos, along with Pluto's other small moons, follows a very circular, nearly equidistant orbit around Pluto and Charon. This regularity in the face of such a chaotic past is surprising. If Pluto's moons were indeed born out of a violent collision, you'd expect their orbits to be more irregular, more chaotic, especially for a moon like Kerberos, which is smaller and more prone to disruption. Yet Kerberos moves in this almost serene orbit, as if everything has calmed down after the initial chaos, and now it's locked into this steady, predictable path. It feels like a contradiction. A moon born from violence now existing in such calm, almost peaceful surroundings. Kerberos, despite its small size and dark nature, forces us to rethink what we know about Pluto's moon system. Its very presence adds complexity to the story of Pluto's formation and evolution, suggesting that there are more layers to this distant world than we originally thought. It's a moon that almost defies easy explanation, as if it's hiding in plain sight, quietly orbiting, waiting for someone to truly understand where it came from and why it looks so different from its siblings. And in the cold, distant reaches of the solar system, it's a reminder that even the smallest, darkest objects can hold the most profound mysteries. Naiad, one of Neptune's innermost moons, drifts through space like a spectral wisp, locked in a delicate dance with gravity. Its orbit is incredibly close to Neptune, only about 23,500 kilometers above the gas giant's cloudy, tumultuous atmosphere, placing it among Neptune's most intimate satellites. To imagine Naiad is to picture something fleeting and fragile, a small and misshapen object just over 50 kilometers across, clinging to existence in the shadow of a vast and storm-laden world. But the mind cannot easily grasp the reality of Naiad's existence. The moon moves in what's called a tilted orbit, weaving above and below the plane of Neptune's equator, a path that creates a kind of cosmic ballet with its sister moon, Thalassa. These two bodies are locked in a peculiar orbital resonance, where Naiad, in its strange, oscillating trajectory, manages to avoid collision with Thalassa as it skips past every orbit, an astronomical dance choreographed by the invisible force of gravity. This rhythmic interplay has an almost hypnotic quality, as if the cosmos itself composed this quiet, harmonious pattern, completely indifferent to time as we understand it. From a human perspective, it's nearly impossible to fathom the forces at play. To be on Naiad, though no human will likely ever set foot on this faint object, would be to experience a world that feels precariously suspended in the vastness of space. Its surface would be dark, cold, and barren, perhaps riddled with craters from impacts over billions of years. From this vantage point, Neptune would dominate the sky, a massive, swirling blue presence that would almost seem close enough to touch. The view would be terrifyingly beautiful, as if standing on the edge of an abyss, knowing that one misstep would plunge you into the planet's thick, icy atmosphere. Though small, Naiad represents something profound about the universe. It doesn't need to be a large or impressive moon to command awe. Instead, its very existence challenges the way we understand orbital mechanics, stability, and time. For billions of years, it has survived this celestial dance, never straying too close to Neptune's gravity well, never drifting too far to escape. There is a kind of delicate tension in that, a balance between chaos and order that mirrors many things in the natural world. The question of what Naiad's surface might be like is a lingering mystery. Its distance from the Sun and proximity to Neptune likely means it is frozen, an inert, icy rock with little to no atmosphere. If there were once geological processes shaping its surface, they've long since frozen in time, leaving only scars from cosmic debris. Yet, even in its stillness, Naiad holds secrets. Its orbital resonance with Thalassa suggests that something more complex lies beneath the surface, perhaps a clue about the forces that once shaped Neptune's moon system or hints about the interactions between gravity and matter at close distances to giant planets. For humans, Naiad feels both distant and familiar, a distant cousin of our own moon but existing in a space governed by vastly different rules. It is a reminder that the cosmos is filled with worlds that operate on principles that seem beyond comprehension, moons that quietly drift through time, engaged in their own silent struggles against the forces of nature. In the case of Naiad, it is that struggle, against the overwhelming pull of Neptune's gravity, against the void of space, against the inevitable collisions, that makes it more than just another rocky moon. It becomes, in a way, a symbol of resilience in the face of cosmic forces so vast that even understanding them feels like trying to grasp smoke with your hands. Thalassa orbits Neptune with an eerie, unwavering consistency, caught in a gravitational grip that has dictated its every movement for billions of years. It's a moon that, despite its modest size, roughly 80 kilometers across, commands a strange, quiet significance in Neptune's intricate satellite system. Thalassa moves so close to its parent planet, at a mere 25,000 kilometers from Neptune's turbulent atmosphere, that its existence feels precarious, like it's constantly on the verge of being swallowed by the gas giant's immense gravity. Yet, it persists, gliding through space with a sense of inevitability, bound to Neptune in a relationship that feels ancient and unyielding. To stand on Thalassa would be to experience an overwhelming sense of isolation. The surface, likely frozen and barren, would offer little in the way of comfort. The sunlight reaching this distant moon is faint, reduced to a dim, cold glow that barely illuminates its landscape. Above, Neptune would loom like a restless god, its swirling storms and vibrant blues casting an ethereal light over Thalassa's icy surface. The sense of being so close to something so immense and powerful would be almost suffocating. From this vantage point, the universe feels both vast and intimately close, as if the very fabric of space is pressing in from all sides. Thalassa, like Naiad, participates in an orbital dance that is astonishing in its complexity. The two moons share an orbital resonance, meaning they avoid collision through a perfectly timed series of oscillations, each slipping past the other in a delicate ballet of gravitational forces. It's a pattern that seems too intricate, too finely tuned to be the product of mere chance, yet it is. Thalassa moves in perfect harmony with Naiad, as if the two moons are connected by an invisible thread that prevents catastrophe by the slimmest of margins. This kind of celestial choreography feels almost alive, like the movements of two dancers who, despite their own inertia, are somehow aware of each other, constantly adjusting their steps to stay in sync. Yet beneath the surface of Thalassa lies a history that remains veiled. It's a moon that likely formed from the debris left over after Neptune captured Triton, the planet's largest moon. This violent event may have disrupted Neptune's original satellite system, scattering ancient moons and material into chaotic orbits. In this cosmic aftermath, Thalassa emerged, shaped by collisions and gravitational forces into the small, irregularly shaped object it is today. Its existence is a testament to survival in a universe where destruction is often the precursor to creation. From a human perspective, Thalassa's story is one of quiet endurance. It's a moon that isn't particularly flashy or unique in the way some of the solar system's more dramatic moons are. There are no geysers like those on Enceladus, no thick atmospheres like Titan's, no volcanic activity like Io. And yet, its very ordinariness is what makes it extraordinary. It exists in the background of Neptune's complex satellite system, almost unnoticed, but its presence is essential. Without Thalassa, the delicate balance of Neptune's moons could unravel, and the precise harmony that keeps Naiad and Thalassa in their shared orbit could collapse. It's a moon that plays its role quietly, without fanfare, but with a kind of stubborn persistence that feels deeply human. The forces acting on Thalassa are almost beyond comprehension. The tides raised by Neptune's gravity pull on its surface, perhaps deforming it slightly, though the moon's solid, frozen nature prevents significant tidal heating. Yet, even this minor tug-of-war adds to the moon's already tenuous existence, reminding us that it is constantly being acted upon, shaped by forces far beyond its control. Thalassa may be small and insignificant on a cosmic scale, but the interactions that define its orbit speak to something much larger. A dynamic system of gravity, resonance, and timing that governs all things in the universe, from the largest galaxies to the smallest moons. In a way, Thalassa's place in the cosmos feels relatable. It exists not because it is powerful or imposing, but because it has found a niche in which it can survive. Its story is one of adaptation, of finding balance in an environment that is indifferent to its existence. It continues to orbit Neptune, locked in its quiet, rhythmic dance, as if acknowledging that sometimes, simply existing within the vast machinery of the cosmos is its own kind of triumph. Margaret is unlike most moons in the solar system. It orbits Uranus in a strange, backward path, what astronomers call a retrograde orbit. There's something unsettling about this. It's as if Margaret has decided to defy the natural flow of things, carving out its own course against the pull of conformity. This little moon, barely 20 kilometers in diameter, has taken on a role as one of Uranus's most rebellious satellites, moving against the grain in a solar system where most objects follow predictable, forward orbits. But this isn't where Margaret's strangeness ends. It also has an unusually elongated orbit, stretching far from Uranus and then looping back in, a pattern that feels like it's testing the boundaries of stability, skirting the edges of gravitational chaos. To imagine being on Margaret would be to stand on a world with an overwhelming sense of distance. Uranus, a pale, aquamarine orb in the distance, would appear so far away it might seem detached, almost ethereal. This distance creates an isolation that is both physical and emotional. Margaret's orbit takes it far beyond the region where Uranus's other moons reside, as if it has intentionally chosen solitude, placing itself at the margins of Uranus's gravitational influence. The cold and darkness would feel oppressive, the silence absolute, broken only by the distant whispers of Uranus's other moons and the faint hum of the gas giant's magnetic field. In this space, it's easy to feel as though Margaret exists on the fringe, not just of Uranus's domain, but of the entire solar system. Margaret's orbit is also one of the most eccentric, meaning that it shifts dramatically between being close and far from Uranus. There's a kind of wild unpredictability in that. Margaret's path feels as though it's on the verge of breaking free, as if one day it might escape Uranus's grasp entirely, flung out into the vastness of space, destined to drift forever in the cold interplanetary void. Yet, something keeps pulling it back. It's trapped in this oscillating, almost rebellious motion, perpetually returning to the planet it cannot quite leave behind. There's a tension there, a push and pull between freedom and gravity that resonates with the human experience of trying to break free from certain forces, only to be drawn back by unseen tethers. This moon is also part of a larger mystery. Uranus is known for its extreme axial tilt, lying almost on its side compared to the rest of the planets. This tilt causes its moons, including Margaret, to orbit in planes that are heavily skewed. It's as if the entire system was knocked off kilter by some ancient, catastrophic event, and Margaret, caught in the aftermath, is still struggling to find its place in the new order. Its orbit might even be a clue to that primordial chaos, a remnant of a time when Uranus was struck by a massive body, forever altering its orientation. Margaret, with its retrograde and eccentric path, could be a silent witness to that ancient violence, carrying within its orbit the scars of a collision that happened billions of years ago. Margaret's defiance of orbital norms also speaks to a deeper truth about the cosmos. While so much in space seems orderly, planets revolving around stars in near-perfect circles, moons obediently following their parent planets. There are always exceptions, outliers that remind us the universe is far from predictable. Margaret is one of those outliers, a moon that refuses to follow the patterns laid out by others, instead choosing a path that seems almost accidental, as though it was placed there by some cosmic quirk. And yet, even in its irregularity, there's beauty. It speaks to the broader complexity of gravitational forces, of how even the tiniest object can find a stable place in the grand scheme, no matter how unconventional its path. For humans, Margaret represents the idea that sometimes, to survive, you have to do the unexpected. It's not the largest, the fastest, or the most well-behaved of Uranus's moons, but it exists, despite its oddities, finding a way to maintain its orbit in a system that doesn't easily accommodate such irregularities. In a universe governed by gravity, Margaret teaches us that there's always room for something a little different, something that operates on its own terms, unafraid of being out of sync with the rest. It's a reminder that sometimes the most intriguing things are found in the orbits that don't quite align, in the paths that seem to defy logic but persist nonetheless. Prospero drifts in the darkness surrounding Uranus, a moon named after Shakespeare's powerful, enigmatic sorcerer. There's a kind of magic in its very existence, a small, distant body, about 50 kilometers in diameter, that moves in an eerie retrograde orbit. This backward journey through space immediately sets Prospero apart from the more ordinary moons that circle Uranus. Its path defies expectation, like a moon that has chosen to wander in the opposite direction from the natural flow, rebelling against the forces that seem to govern everything else. And yet, Prospero's defiance isn't wild or chaotic. It follows a steady, stable path as if it knows exactly what it's doing, navigating a delicate balance of gravitational forces with a kind of quiet determination. To imagine standing on Prospero is to step into a place of profound isolation. Uranus, a pale, distant giant, would loom faintly in the sky, barely illuminating the icy, cratered surface beneath your feet. The cold would be beyond anything familiar, a freezing stillness where no warmth from the sun can penetrate. But even in that cold, there's something strangely alive about Prospero's journey, a sense that it exists not by accident but by intention. Its retrograde orbit hints at a more complex story. Perhaps Prospero wasn't always a part of Uranus's system. There's a theory that Prospero, like some of Uranus's other irregular moons, was once a wandering body, a rogue asteroid or comet captured by the planet's gravity billions of years ago. If that's true, then Prospero's origin lies far beyond Uranus, in the chaotic, unpredictable regions of the solar system where objects drift freely, untethered by any one planet. This moon's journey through space might seem slow and unremarkable at first glance, but the dynamics that govern its orbit are nothing short of extraordinary. Retrograde moons like Prospero don't follow the usual rules. Their orbits are often highly eccentric and inclined, meaning Prospero doesn't just move backward. It does so at a steep angle, cutting across the plane where most moons reside. It's as if Prospero is constantly asserting its independence, its orbit a statement of nonconformity. And yet, despite its irregularity, Prospero manages to avoid the gravitational tug-of-war that could destabilize it. It moves through space with a kind of graceful resilience, proving that even in the face of overwhelming forces, it's possible to carve out a place of stability, to find a way to exist without being pulled apart. What's even more mind-bending is the fact that Prospero shares this outer realm of Uranus with a handful of other irregular moons, Setebos, Sycorax, and others. Together, they form a kind of ghostly collection of objects that defy the usual logic of moon systems. They're not neatly arranged or synchronized like the inner moons, but scattered at odd angles and eccentric paths, each one following its own strange, retrograde orbit. This gives Uranus a chaotic outer realm, a place where gravity plays by different rules, where moons like Prospero challenge our assumptions about how celestial bodies are supposed to behave. It's almost as if Prospero and its companions exist in a different world entirely, one where the familiar laws of planetary motion don't quite apply. Prospero's existence also speaks to the chaotic early days of the solar system, when planets and moons were still forming and gravitational interactions were violent and unpredictable. In those early epochs, objects like Prospero may have been tossed around like dice, moving from one gravitational well to another, until Uranus's pull finally caught it. Even now, there's something transient about Prospero's orbit, as if it's still not fully settled, still capable of being thrown off course by a sudden, unseen event. It's this sense of precariousness, the idea that Prospero's journey through space is not yet complete, that adds to its mystique. For humans, Prospero's story is one of adaptation in the face of forces beyond comprehension. It's a small, icy moon, orbiting a distant world in a way that defies expectations, and yet it endures. It reminds us that even when the path seems backward or the journey unconventional, there's a way to find stability, to exist in harmony with forces far greater than ourselves. Prospero doesn't follow the traditional rules, but it has found a way to exist on its own terms, a quiet rebel in the vastness of space. And in that, there's something deeply human, a reflection of the urge to carve out our own path, even when it seems the universe is moving in the opposite direction. Setebos, orbiting Uranus in the distant reaches of its gravitational hold, seems almost like a forgotten moon. Far from the bright attention given to more prominent bodies in the solar system, Setebos moves in a peculiar, almost ghostly orbit. It's retrograde, moving against the direction that most moons travel, as if it's stubbornly rejecting the patterns laid out by its fellow celestial companions. This backward motion, combined with its irregular orbit, gives Setebos an eerie sense of detachment. It doesn't follow the expected order, instead charting a path that feels isolated, even rebellious. To imagine Setebos is to imagine a place where the rules seem slightly off. Its surface, likely pockmarked with ancient craters, tells the story of a moon that has seen little change over billions of years. The sunlight here is faint and cold, almost absent. Uranus, a pale and distant giant, dominates the sky, but its presence feels remote, as if the planet has little direct influence over the small moon. In this outer realm of Uranus's satellite system, the laws of motion and gravity become less predictable, less rigid. There is something unsettling in the stillness, the sense that Setebos, with its peculiar orbit, doesn't quite belong where it is. One of the most intriguing things about Setebos is its possible origin. Like other irregular moons of Uranus, Setebos may not have formed around the planet at all. Instead, it might be a captured object, a wanderer from the Kuiper Belt or beyond, caught by Uranus's gravity long ago. If this theory holds true, Setebos' journey began far from the planet it now orbits, in the cold, distant fringes of the solar system where icy bodies drift aimlessly. This capture event, however ancient, speaks to the chaotic early days of the solar system. a time when gravitational encounters were violent and planets like Uranus snatched up rogue objects passing too close. Phobos, then, carries within its orbit a history that reaches beyond Uranus, a reminder of the solar system's primordial chaos. What makes Phobos particularly fascinating is its relationship with Uranus's other irregular moons. It shares this distant, retrograde realm with moons like Prospero and Sycorax, each following its own eccentric orbit. Together, these moons create a kind of gravitational ballet on the outskirts of Uranus's influence, constantly pulling on one another in subtle, almost imperceptible ways. The orbits of these moons, including Phobos, are not neatly aligned but scattered, tilted, and eccentric. It's as if they exist in a realm where order has given way to randomness, where the gravitational pull of Uranus has created a fragile, dynamic system on the brink of instability. This delicate balance between chaos and order, between randomness and structure, is both mesmerizing and unsettling. There's also the question of Phobos' long-term stability. Its orbit, like those of many irregular moons, is eccentric enough to suggest that its future is uncertain. Over time, gravitational interactions with Uranus, or perhaps with the other irregular moons, could destabilize its orbit. It may be flung further out into space or drawn closer to Uranus, where tidal forces could rip it apart. This potential for future chaos hangs over Phobos, a reminder that even celestial objects are not immune to the unpredictability of the cosmos. In the vast timescale of the universe, Phobos' current path may only be a temporary one, a fleeting moment in a much longer, more chaotic history. From a human perspective, Phobos represents the fragility of existence. It's small, distant, moving in a way that seems contrary to the expected order of things, and yet it persists. The forces acting upon it are immense, beyond anything we can truly comprehend. Yet Phobos finds a way to navigate these forces, holding its place in a chaotic, gravitational web. There's something deeply relatable in that. This idea of finding stability in a universe that seems to constantly push and pull in different directions. Phobos doesn't dominate its environment. It doesn't command attention or reshape the space around it. Instead, it adapts, finding a way to exist in the margins, quietly defying the expectations of how a moon should behave. In this quiet defiance, Phobos becomes a symbol of endurance, a reminder that even in the most uncertain, chaotic circumstances, there is a way to persist. As we bring this journey through the mysterious moons of our solar system to a close, I hope you've been as captivated by these distant worlds as I have. Whether it's the icy depths of Europa, the volcanic fury of Io, or the alien lakes of Titan, each moon has its own unique story, waiting to be explored even further. Thank you for joining me on this adventure through the cosmic neighborhood we call home. If you enjoyed diving into these fascinating worlds, why not leave a like and help others discover the wonders of space? And if you want to keep wandering with us through the mysteries of the universe, make sure to hit that subscribe button. There's always more to explore here on Quiet Universe. Until next time, keep your curiosity alive, and I'll see you among the stars.